Okay, we are live finally. Hi students, I am here back on this channel. Can you but let me know if you can hear me and see me properly? Correct? Hi Pavish. Hi Ammu. ठीक है, let me know in the chat box बच्चा if you can hear me and see me properly, see the screen properly, whatever it is written on the screen. As you can see, today we are going to start P block group 14 and group 15. Actually, we have already started P block, right? I'm going to teach you P block in 3 parts. First part we've already done where I introduced what P block elements are. Then we learned a lot about 13th group. Did all the PYQs possible for the 13th group. Then we started a little bit of 14th group. Right now we're going to complete the 14th group and 15th group along with the PYQs, along with the NCERT, everything we're going to do in this session. Just let me know if you can see me and hear me clearly. Please let me know that. Whoever is watching, just put a thumbs up in the chat box, right? Put a thumbs up. And also introducing myself again, I'm pretty new on this channel, I know. My name is Nandini ma'am, and right now I'm going to teach you inorganic chemistry for your NEET 2024 attempt, right? Okay, please let me know if you can see and hear me properly. In the chat box, please let me know whoever is watching. Okay, otherwise I'll hear it. 1 second. ठीक है. Right. Okay, please let me know if you can see and hear me properly. In the chat box. ठीक है. Perfect. I can hear myself clearly. So in this session, what you're going to expect, that we're going to complete 14th group. For the 14th, in the last lecture, bacha, I already taught you the basic atomic properties. What were they? They were the ionic radius, the ionization energy, the density trend, the electronegativity trend, the metallic character trend, melting point, boiling point. All these trends we've already done in the last class. Right now, we're going to look at the reactions of group 14 and the entire group 15 with the all the PYQs ever asked in your NEET exam, and also what can you expect in your NEET 2024. So this is going to be a well-rounded session. After these 3 parts of P block, you don't have to read any NCERT. My notes will be enough. You can depend on me for your NEET 2024, right? Because this is handmade. This is handmade just for your NEET exam, right? So again, I'm going to start with telling you what is the structure of your periodic table, right? Whenever we're reading about any block elements, doesn't matter what. Okay, previously there used to be even S block elements in your course. Right now there are no S block elements. We just have P block elements, right? So, bacha, these are your P block elements except helium, right? That was the question I asked in the last lecture. Helium is not a P block element because its electronic configuration of helium is just 1s2, right? So the last electron here enters the s orbital. Hence, helium is not a P block element. It is actually a S block element. But we read its properties with the P block because it is similar to the other noble gases. That is the reason we study. Otherwise, it is a S block element. Is this thing clear to everybody? Now, in the P block elements, what happens? The last electron actually enters the P subshell, right? Now, because the P subshell has how many orbitals? The P subshell has 3 orbitals. Hence, the maximum number of electrons that it can get is actually 6 electrons, right? And that is why we have a total of 6 groups in the P block elements, because total 6 electrons can enter. Hence, if in the P subshell there is 1 electron, the group is 13. If in the P subshell there are 2 electrons, then the group is 14. This is 3, this is P4, this is P5, and this is P6. So that's how we actually classify these elements. Correct? So this is the P block that we're going to read about. The 13th group is already completed. I've told you everything that is possible about the 13th group. And also we are studying according to the new reduced syllabus. We are not studying the entire NCERT because it's not going to come in your NEET exam. We're going to study according to the new NTA syllabus, which I told you in the last class. I've described the syllabus. I've put a screenshot which NTA had shared, right? We're just going to do only those topics which are there in our course. And right now we're studying about the 14th group. But before that, I have a news to share to everybody, a very good news for all the NEET 2025 aspirants. I'm sorry, I also teach JE students, right? So that's why JE keeps coming out of my mouth. So I also teach JE students, but here I'm teaching the NEET students also. So for the NEET 2024, your exam is going to be in just 2 months, right? You just have 2 months for exam. And if you're getting serious about your exam at this point of time, don't worry. 2 months are more than enough to crack a NEET exam. That is my promise to you guys. And if you want to get enrolled in a crash course, okay, this is the online crash course that Vedantu is offering. What will be the benefit of joining this course, ma'am? If everything is on YouTube, why do I need to join any crash course? And why? Because bacha, if you join this crash course, what happens? You get into a schedule, right? You get into a schedule. You know कि today I'm going to take these lectures, tomorrow is my test from these topics. So you get and start working on that schedule, which is very crucial. These 2 months are like the basic months for your NEET exam. Everybody is aware of that. And so these are some of the benefits, that you even get live doubt clearing sessions, right? When you join this crash course, whatever doubt you have during the class, after the class, before the class, all the doubts you can clear in the doubt clearing sessions. You will have 23 full length mock tests, and we all know how much importance are these mock tests, right? So that you're ready for the final battle, right? To get myself ready for the final battle, you need to take tests. If you are not solving questions, bacha, you are not you're not going to be able to solve questions in the exam. There is no ifs and buts about it. That is a true and tested method. Once you get a hang of solving questions, what kind of questions? Like 45 questions in chemistry, 45 in physics, and then whatever 90 questions in your biology. Like when you get a hang of it, of doing those questions in 3 hours, that is very important, so that you do not panic on the last day, right? And there are also 15 part syllabus mock tests, which means what? 23 full length means what? The entire syllabus will be covered in there. And in the 15 part syllabus mock test, only part of the syllabus will be there. And there is also comprehensive test analysis. What is meant by that? For example, you took a test, right? There were some topics asked from that test, and now after the test analysis, which the teachers will do, and even some computers, AI technology will be used by that, and you will get to know what topics you're weak, what topics of you are strong. So you can enroll this batch. The price is just 4,000 rupees. It is not any, and because this is a launch price, so therefore this is less right now, and it has already begun on the 4th March 2024. Okay? Good afternoon, bacha. Can you hear me? Hi, Jyoti. Hi, Bisri. Okay, so this is about the crash course. This is for those students who are taking the NEET 2024 exam. But if you're a NEET 2025 aspirant, then you have even bigger good news with you, that Vedantu is now in your city, which means what? We now are having offline classes along with the online classes. Right, so Vedantu is in your city, and you can do your JE or your NEET preparations with Vedantu. If you love Vedantu, if you love the teachers of Vedantu, if you love learning from Vedantu, if you love the culture, and you know how much teachers are dedicated to your JE or NEET preparation, then you can join this, right? And for more information, I would like to tell you that these are the cities. In Punjab, it is present in Patiala. In Delhi, if you are in Delhi, there is a center in Delhi. If you're in Rajasthan, there is a center in Jhunjhunu. If you are in Maharashtra, there is a center in Pune, Nagpur, and Aurangabad. If you are in Karnataka like me, okay, I'm also in Bengaluru, and there is a center in Bengaluru, right? And you can even meet me in Bengaluru if you're here right now. Then in Tamil Nadu, there are centers in Chennai, Coimbatore, Madurai, and Trichy. In Telangana, the centers are in Hyderabad. In Andhra Pradesh, the centers are in Vishakhapatnam, Vijayawada, and Guntur. And in Bihar, it is in Muzaffarpur, right? These are the offline centers, right? If you want to make use of the offline classes, which are obviously better than the online, because you have a schedule, you have a day-to-day thing to do, you get up, you go to a place, you come back, you have homework, you have tests the next day, right? So you get into a schedule, which is very crucial, especially for someone who's preparing for JEE or NEET exam. Otherwise, you know what? You can be the smartest person ever, but if you're not hardworking, if you're not disciplined, these exams require that. These exams, obviously, quite smartness is required, right? Somewhat smartness is required, but On the top of that, because the course is so much, what you actually require is discipline, is hard work. How do you get that? Through getting into a schedule, right? So also, if you are interested in joining these offline centers, if you are near these cities or in these cities, then you can join these centers, right? And also, before joining, you can take our IV SAT exam. What is that? That is a kind of a scholarship exam test. Like if you take this test before enrolling into the Vedantu, what you can get up to 70% of scholarship on whatever course you are opting for, right? We have like 100 crore plus scholarship pool, bacha, which is a very, very high pool, right? And you can register right now. The link is in the description box below. Good afternoon, Somasani. Okay, and I will just show you the description box, right? I will just show you the description box. For example, this is my video that you're watching right now. Okay, and if you scroll down, you will see something like this, right? So this is where all the links are present. For example, if you want to go for the offline center, Vedantu Learning Center, then you can click on this link. And if you want to join the NEET 2024 crash course, then you can join this link. Just click on this link and you'll be redirected. If you want to book an appointment with the offline center, you can again do that. Okay, so this is some of the things that I wanted to tell you to help your preparation for your NEET exam, right? Now let's get back to our learning, right? So this was some of the resources that I could share with you if you're preparing for NEET 2025, NEET 2024. What you can do, these are some resources, you can make use of that. And it's all up to you, right? Because you are big students now, big bacha now, big child now. You can make your own decisions. So right now we're going to talk about, but we're obviously going to teach online, bacha. Okay, we're going to teach online. Right now I'm going to do that. Let's start with the topic, group number 14. In the 14th group, we already discussed all the atomic properties, right? I discussed every atomic property with you, which is the radius, the ionization energy, the density, melting point, boiling point, electronegativity, metallic character. We've already discussed that in the last lecture. If you haven't seen that, go and see that. Right now, we're going to discuss their chemical reactivities, which are very, very important. Remember, no matter what group we're doing, we're going to follow a trend, right? A trend is going to be followed. ठीक है बच्चा? How many hours? But this class is going to be maximum 2-hour class. ठीक है? 2 hours में we're going to complete the entire group 14 and group 15. 2 to 2.5, maybe it can stretch, otherwise 2 hours. I will just make sure to end it in 2.5 hours. ठीक है? Now next bacha, reactivity towards oxygen. No matter what group you are studying, you can be studying group 13, 14, 15, 16, 17, 18. There's a trend that we're going to follow. First of all, we're going to study about all the trends, the atomic property trends, the radii, the ionization energy, electronegativity, density, what is the trend within the group. The next thing we're going to study are their chemical properties, right? With every group, right now there is going on group number 14. With group number 14, we're going to study its chemical reactions with three things. Three things, what are that? Hydrogen, oxygens, and halogens, right? So these three chemical reactions we're going to study in every group. Okay? So number first, with the 14th group, we're studying the reactivity towards oxygen. Okay? Oxygen. So whenever group number 14, I'm going to write group number 14 as M. Okay? So whenever group number 14 reacts with the oxygen, it forms two kinds of oxide. What are those? That is a MO kind of oxide and also MO2 kind of oxide. Right? Why? Because group 14, we're talking about group number 14. Remember this. Group 14 has what kind of electronic configuration? It has NS2, NP2 kind of configuration, right? So what are the oxidation states it can show? It can show either the 2 electrons can go away. So it can show either +2 oxidation state, or both the 4 of the electrons will go away. So it can either show +2 or +4 oxidation state. So these are the common oxidation states shown by group 14 elements. Remember this thing, +2 and +4. The next thing, now look at the group 14. Group 14 consists of carbon, silicon, germanium, tin and lead, right? So as I'm going down the group, what happens to the stability of the oxidation state? When you're going down the group, I'm writing it here, stability of +2 increases, right? And +4 decreases. Remember this. As you're going down the group, the stability of the higher oxidation state actually decreases. Why does it happen? I discussed it in the last lecture due to inert pair effect. What was that we discussed in the last class? Go watch that lecture. Right? So therefore, as we go down the group, right now you have to remember +2 stability is increasing and +4 bigger oxidation state stability decreases. This trend is followed in all of the groups. Hence, the oxides form will be the MO oxides plus the MO2 kind of oxides. Remember this thing. Okay? Now, every element over here, every element, this is called, bacha, this is called the monoxide, right? And this is called the dioxide, right? This is called the dioxide, that is called the monoxide. Okay, the next thing that you should know is every element here forms the monoxide. Okay, all group 14, all group 14 elements form the MO type of oxide, except there is one exception, except very important, because exceptions are asked in your exam, except your SiO, which is only formed at high temperature, only formed at high temperature. Remember this thing. Okay, because exceptions are very important. All the elements form monoxides except what, but just silicon oxide, which is only formed at high temperature. Now we're going to talk about the MO2 type of oxides. All forms MO2 type of oxides as well. The next thing that is very important in the oxide is their acidity and the basicity order. Right? I'm going to write all kinds of monoxide. Monoxide as CO, silicon oxide, and then it will be germanium oxide, then it will be tin oxide, right? And then it will be PB oxide. Correct? So these are the kind of monoxides formed. What are the dioxides formed? The dioxides will be CO2, SiO2, GeO2, right? SnO2 and PbO2. Why was I saying two kinds of oxides are formed? Why was I saying two kinds of oxides are formed, bacha? Now look at this series. Here what is the oxidation state of carbon? Here it is +2. Here every element is in +2 oxidation state. Correct? And here every element is in +4 oxidation state. Correct? Everybody agrees with this thing here, and that's what I told you. Group 14 shows two kinds of oxidation state, +2 and +4. Hence, two kinds of oxides are formed. This thing is clear. Now what is the next question? Very asked question, right? Very probability of asking this kind of question is which oxide is acidic and which oxide is basic. So CO, bacha, is a neutral oxide. Remember this thing. This is a neutral oxide, right? And germanium oxide is a acidic oxide. It is an acidic oxide. Similarly, your tin oxide and your lead oxide is actually amphoteric oxide. Amphoteric oxide. Please, this is a very important order. Amphoteric means what? It reacts both with acid and the base. Okay? The next kind of oxides are the dioxides. Okay? Now, remember one more thing. I'm going to write one more thing in this star mark here. Okay? What I'm going to write? That, bacha, as the oxidation state of oxide increases. What I'm saying? As oxidation state of oxide increases. What happens? As the oxidation state of oxide is increasing, what is happening? The acidic character also increases. Acidic character also increases. Remember this thing. What is meant by that? For example, here in carbon monoxide, the carbon is in +2 oxidation state, right? In carbon dioxide, the carbon is in +4 oxidation state, right? So the oxidation state of carbon here is increasing. Because the oxidation state is increasing, I just told you, as the oxidation state increases, the acidic character also increases. So these two oxides, bacha, these two oxides which are now in +4 oxidation state will be acidic oxide, right? This one will be less acidic, correct? And this is, bacha, again amphoteric oxide, amphoteric oxide. Okay? So this is the acidity basicity order which you should know, which is a very frequent question asked in exam. ठीक है. The next question that can be asked in exam is actually, okay, I'm going to write here in this free space. The next is, bacha, I just told you this carbon monoxide, can you see here? This carbon monoxide here, again go back to here. What did I say? The carbon monoxide here, the carbon is in +2 oxidation state. Everybody can see that. The carbon here is in +2 oxidation state. But I told you that idhar pe, on the top of the group +4 oxidation state is more stable, right? And as you go down the group +2 oxidation state, stability increases. So carbon is not stable in +2, but it is stable in +4 oxidation state. Hence, carbon which is here in +2 will want to convert into the +4 oxidation state, isn't it? Will want to convert into the +4 oxidation state. So what it is happening to carbon monoxide? It is undergoing oxidation, right? It is undergoing oxidation. Hence, carbon monoxide, bacha, act as a very, very strong reducing agent. Strong reducing agent. Did you understand this point? Did everybody understand this point? Because carbon monoxide is in +2 oxidation state, it is not stable in the +2 oxidation state because it wants to convert into the +4, because carbon is stable in +4 oxidation state. Hence, it will want to oxidize itself. So, one which oxidizes itself acts as a very, very good reducing agent. One which gets oxidized is itself a very, very good reducing agent. Remember this inverse relationship. If I am getting oxidized, I am actually a very good reducing agent. Hence, carbon monoxide, but as a very, very good reducing agent. Similarly, the next thing I'm going to ask you, the question is to you guys. Now I'm going to ask you, what is the nature of PbO2? Is it a good oxidizing agent or is it a good reducing agent? PbO2 here is in +4 oxidation state. Can everybody agree with that? PbO2, the Pb here is in +4 oxidation state, correct? But I told you as we go down the group, the stability of +2 actually increases. Hence, Pb wants to remain in +2 oxidation state. So, Pb wants to convert into +2 oxidation state. Hence, it is getting itself reduced. Therefore, bacha, PbO2 acts as a very, very strong oxidizing agent because Pb here is not stable in the +4 oxidation state and it wants to get converted into the +2 oxidation state. Is this thing clear to everybody? Is this thing clear? Shall I move forward? Very, very interesting points. What did I tell you right now? With the reactivity with oxygen, what did we learn? We learned that group 14 reacts with oxygen and forms two kinds of oxide. One is a monooxide and the other one was the dioxide, like this, right? Here the oxidation state of the element was +2. Here the oxidation state of element is +4, right? Then we discussed their acidity and basicity order of oxides, which is very much asked in your exam. I will show you even PYQs related to that, right? And I also told you as the oxidation state is increasing, the acidic character of the oxide increases. Number third point. Number fourth point is what will be a good reducing agent? What makes a good oxidizing agent? We discussed that on the top of the group, higher oxidation state is stable. On the downward of the group, the lower oxidation state is stable. Hence, accordingly, they will act as a reducing agent or a oxidizing agent. Everybody understood this? So this is all about the reactivity with oxygen. All the questions that can be asked, we discussed over here. Now look at the AIPMT 2011 mains question, right? This is a PYQ. Which of the following oxide is amphoteric? I just discussed with you. Who can answer this question? Which of the following oxide is amphoteric? Who can answer this question? Yes, strong oxidizing agent. You're absolutely correct. Karthik and Bisiri. Hanji. Who can answer this question? Remember, this is a PYQ. Every PYQ which has ever been asked from the group 14, group 15, they are going to be here. Right? Which of the following oxide is amphoteric? Yes, Bisiri. Can you answer this question? I just discussed with you which of these is an amphoteric oxide. Yes, please answer me. Please, anybody. See, SiO2. Beta, SiO2 was not amphoteric oxide. SiO2, I told you, it is an acidic oxide. SiO2 was a acidic oxide. ठीक है? Yes, you are right. A answer was given by, first of all, Nitish Prajapati. Then Karthik also gave the correct answer. Then Somasani and also Nitish again. ठीक है, the answer is tin dioxide. See, we just discussed the acidity basicity order. Can you see? The tin dioxide and the lead dioxide are amphoteric. Germanium is less acidic and the CO2, SiO2 are actually acidic oxide. ठीक है? ठीक है, everybody understood this? Now we are talking about the reactivity towards water. What kind of reactivity they show towards the water? So just remember that carbon, silicon and germanium, all these three things. All these three things, if I try to react them with water, bacha, what happens? There is no reaction. Remember this thing. These upper wali तीन, carbon, silicon and germanium, do not show any reaction with water. ठीक है, the next is बच्चा tin. Tin plus H2O, we are talking about tin plus H2O, they actually give a reaction, right? And with what kind of water it reacts? It reacts with gaseous water, which means what? It is reacting with the steam water. Tin reacts with steam and forms SNO2 plus your hydrogen. ठीक है? And similarly, your lead. What happens with lead, bacha? If I react lead with H2O2, H2O, what will happen? Again, no reaction happens. Remember this thing. There is no reaction. So only in the group 14, only your tin reacts with water and forms hydrogen gas, right? And none of them reacts with water. Why does lead do not react with water, bacha? Because instead on lead what happens? There is a protective oxide layer. Protective oxide film. On lead, what happens? If lead is kept in air, a protective layer of oxide is formed on it, which actually prevents it from reacting with water, right? So this is the reason for lead. For carbon, silicon and germanium, there is no reason. They just don't react with water. Only tin reacts with water. ठीक है? Everybody understood this? Now next question. Now we have discussed the reaction with oxygen, reaction with water. Now we're going to discuss reaction with halogens. Again, the one thing that you have to keep in mind, what are the two common oxidation states of group 14? It is +2 and +4. These oxidation states are very, very crucial to form compounds. If the oxidation states are +2 and +4, most common oxidation states are +2 and +4, then what kind of halogen compounds can they form? They can form two kinds of halogen, which is MX2 and MX4, isn't it? है ना? X is बच्चा what? X is any halogen, can be fluorine, chlorine, bromine or iodine. Correct? Correct? So, because it has two common oxidation states, +2 and +4, therefore it forms two kinds of halides, which is dihalide. This is called a dihalide and this is a tetrahalide because there are four halogen atoms, hence it's called the tetrahalides. As I've written here, tetrahalides and dihalides, two kinds of halides are formed. Okay? Now what thing you have to keep in mind? For the MX2 type, all forms MX2 halides except, I'm only writing the exception here, except carbon and silicon. Except carbon and silicon, all other elements, which is germanium, tin and lead, forms the dihalides. Why does carbon and silicon not form dihalides? Because carbon and silicon are only stable in their +4 oxidation state, right? As we go down, then the lower oxidation state is stable, only then the +2 is stable. +2 is not stable with carbon and silicon, hence they do not form MX2 type of halides. Okay? Similarly, who forms MX4? Bacha, all forms MX4. All forms MX4 type of halides. All atoms, carbon, silicon, germanium, tin and lead, all forms. Okay? And okay, there is one exception, bacha. Which tetrahalide is not formed? Except PbI4 is not formed. Very, very crucial point given in your NCERT, that your lead tetraiodide is not formed. Okay, why? Because your lead and I bond is very weak bond, right? This bond, because lead is a big atom, iodine is a big atom, both are big atoms, and they will form a very long bond, and long bonds are not stable, hence it is very weak and it is not formed. So all mx4 kinds of halides are formed except PbI4, and mx2 except carbon and silicon all forms mx2 type of halides. Is this thing clear to everybody? Is this thing clear to everybody? Okay, the next is we are going to discuss are they covalent or ionic in nature, right? What is the meaning of ionic? Again, who can tell me? What does ionic mean? Ionic means, for example, the ionic best reaction is between Na and Cl. What happens? Na gives one electron to Cl, and what happens? Na plus and Cl minus is formed. This is called a ionic reaction. So what is happening in ionic, bacha? Electron transfer is happening, and for the electron to transfer, what is required? I have to lose one electron. To lose one electron, I require ionization energy, right? Now to form mx4 type of halide, for example, 4 matlab it has to be in the +4 oxidation state. So I have to lose 4 electrons, right? To lose 4 electrons to form a ionic kind of halide, to lose 4 electrons, I would need 4 ionization energy, which is a lot, which I cannot do. Hence, mx4 kind of halides, bacha, will be covalent. Okay? mx4 will be all covalent. All mx4 will be, bacha, covalent halides for the same nature. Covalent means what? They are formed by sharing of electrons, right? Covalent bonds are what? Where the electron pairs are shared. Ionic is where the complete transfer of electrons happen. So these mx4, because it is in +4 oxidation state, always form covalent halides. But again, because this is chemistry, there is exceptions everywhere. Except, bacha, what? Except tin F4, okay? Tin tetrafluoride and your PbF4. Why? Why? Again, this actually depends on the Fayon's rule, which you learn in chemical bonding, right? You learn in chemical bonding the Fayon's rule. What happens in Fayon's rule? That as the anion is smaller in size and the cation is bigger in size, the type of bonding formed between them will be ionic bonding, right? Fayon's rule, which we learn in chemical bonding, due to that, what happens? Due to tin tetrafluoride and lead, tin and lead are big atoms. Can you see? Bigger atom, bigger cations and smaller anions form ionic bonds. Okay? Now, if they are covalent in nature and they are tetrahalides, hence their structure will be sp3, which means they are tetrahedral in nature. Does anyone have any issue in this? Okay, everybody can see this, that these are tetrahedral in nature. Everybody can see this? Okay? Okay? The next thing, बच्चा, that you should know, मैम 11th में दो groups हैं कि 6 of me. बच्चा, beta in 11 there are just 2 groups, 13th and 14th. Right now we're talking about 14th group only. In 11th there are 2 groups. In 12th the rest of the 4 groups are there. ठीक है? So this thing is clear to everybody. Now let's talk about the mx2 halide. What happens in mx2, बच्चा? In mx2 all are ionic. This is, बच्चा, ionic in nature. है ना? Because you have to lose only, this is in +2 oxidation state, so I have to lose only 2 electrons. It is easier to provide ionization energy 1 and 2, just 2 ionization energies are required. Hence, most of these atoms are ionic in nature. Okay? Now let's talk about the stability. What happens to the stability? Let's talk about the stability of dihalides. For example, germanium dihalide is less stable than tin dihalide, then Pb dihalide. Why is that the case? Because I told you, as we go down the group, the stability of the +2 oxidation state is increasing, right? As I am going down the group, the stability of +2 oxidation state increases. Hence, the +2 dihalide PbX2 is actually more stable. Everybody understood this? Now, if you are going to talk about the stability of tetrahalides, what will be the stability, bachcha? What will be the stability? Okay. What will be the stability of tetrahalides? The tetrahalides will be PbCl4 will be more stable, then PbBr4 will be more stable than PbI4. Remember this trend. Remember this trend. Why is this the trend, bacha? PbCl4 is more stable than PbR4, and PbI4 is not even known. Not known. It doesn't even form. Remember this. It doesn't even form the PbI4. Okay? So this is the stability order, very very important, given in your NCERT once again. Okay, now we're going to discuss some more important things about the tetrahalides and the dihalides, which is bacha, remember one more thing. The one more thing is, when I take the carbon tetrahalide, which is CCl4, right? The carbon tetrahalide, if I try to react it with water, bacha, there will be no reaction. Remember this thing. If I take carbon tetrachloride and try to react it with water, there will be no reaction. Why? The question to this, why there is no reaction? Why, ma'am? Because bacha, carbon do not have any d orbitals, right? The carbon do not have any d orbitals, hence it will not react with water. With water, what is happening? You are taking in water. I already, all of my 4 valencies are satisfied with chlorine, है ना? I am a carbon, I can form maximum 4 bonds, and all the four bonds are satisfied with chlorine, and if a water try to attack me, I have no d orbitals, hence I will show no reaction. ठीक है? Now I will tell you one more thing. The other thing is that the silicon tetrahalide, or even your germanium tetrahalide, or even your tin tetrahalide, or even your Pb tetrahalide. Remember these things. All of these elements, from your silicon to lead, what happens? All of them have d orbitals in it. Only the first element of each group, first element of every group, whether it is group 13, 14, 15, 16, 17, 18, every first element of each group will, bacha, do not have any d orbitals. Rest of all the elements have d orbitals. Because all of these have d orbitals in it, what can happen? The water molecule can attack over here. Because they have vacant d orbitals, they all, bacha, act as Lewis acids, right? What is the definition of Lewis acid? Lewis acid means if I have any vacant orbital in me, something can attack me, है ना? Because I'm saying they have vacant d orbitals in it, hence another element can attach to them, hence they act as Lewis acid. But CCl4 do not act as Lewis acid. Why? Because again it has no d orbitals, therefore CCl4 doesn't act as Lewis acid. Rest all of the tetrahalides act as Lewis acid. Is this thing clear to everybody? Is this thing clear to everybody? Now I'm going to ask you a very very important question. The important question is, let us look at the PbX2. I'm going to form two. One is the dihalide, the other is the lead tetrahalide. Which of these is more stable? You have to know, tell me the stability order. What is the stability? Is PbX2 more stable or is PbX4 more stable? The next is between germanium dihalide and germanium tetrahalide. Which is more stable? Who can answer this question for me? I just told you, as we go down, stability of +2 increases and the stability of +4 decreases. Now let me know in the chat box, which do you think will be more stable between PbX2 and PbX4? PbX2 Oasis has replied PbX2 very very good. Why? Because as we go down the group here, +2 oxidation state, bacha, is more stable, and with the germanium here, +4 is more stable, hence for this GeX4 is more stable, right? So this is how the questions can be asked from your reactivity with halogens. What did we learn in the reactivity with halogens? We learned that group 14 forms two kinds of halides, dihalides and tetrahalides, right? The tetrahalides are mostly covalent in nature. There were few exceptions, right? Due to the Fayon's rule, there are few exceptions. The second thing is the dihalides were mostly ionic halides. Okay? The third thing that we learned was their stability order, right? So as we go down the group, the stability of +2 increases, and on the top of the group, the stability of +4 is more. The next thing we learned is all the tetrahalides act as Lewis acids because they have d orbitals, but the carbon tetrahalide do not act as Lewis acid because it do not have any d orbitals. That is it. The halogen reaction with halogens complete. Very, very easy topic, right? Let us move forward. Now this is a question asked in your uh, NCERT. Problem number 11.6. SiF6 2 minus is known, whereas SiCl6 is not known. Give possible reasons. This is a fact. Okay, this is a very, very important fact. See, these kind of facts which are asked in questions somewhere or the other in the NCERT, they get asked in your directly in your NEET exam. I will show you how is this question asked directly in your NEET exam. So NCERT is very, very important. But you do not have to read NCERT after you have attended one lecture, because I write down everything present in your NCERT but in bullet points, so it is easier to remember. Okay? Now tell me, why is F6, SiF6 is known but SiCl6 is not known? Why, bacha? Because silicon in SiCl6 2 minus, SiCl6 2 minus. What is the oxidation state of silicon over here? The silicon is in +4 oxidation state, isn't it? So silicon is in +4. Silicon is very chotu molecule, very small molecule over here. And chlorine is comparatively a bigger molecule. ठीक है, तो SiCl6 is not known because why बच्चा? Because silicon +4 is very small to accommodate 6 chlorine atoms. Remember this thing. Okay? To accommodate 6 chlorine atoms, Si+4 is very, very small. Okay, everybody understood this? Yes, due to the size. Yes, due to the size. You're right, Ovice Raja. Okay? This is the answer to this question. Now, we are going to look at this PYQ. Which of the following is incorrect statement? NEET 2019, very, very recent PYQ asked from group 14. Which of the following is incorrect? GeX4 is more stable than GeX2. SnF4 is ionic in nature. PbF4 is covalent in nature. And SiCl4 is easily hydrolyzed. SiCl4 is easily hydrolyzed. Who can tell me? Who can tell me which is the incorrect statement? I am looking at the chat box once again. Once again. Please answer this question right now. We've discussed everything. Which is more covalent, which one will be more ionic? है ना? I told you the exception as well. Did I not tell you? Answer I have received C. B, C, somebody has written. Pavish has given C answer. And ठीक है. ठीक है. Which is incorrect. Bacha, PbF4 it will be ionic in nature. The answer, correct answer is C. So many people have given. Pavish, Somasani has given right answer. Right answer. Kavya has given right answer. Khushi has given right answer. PbF4 is covalent in nature. They have asked you the incorrect statement. PbF4, so incorrect statement is this. PbF4 is covalent. No. PbF4 is ionic in nature, right? Due to the Fayon's rule, it is ionic in nature. I just told you. PbF4 and SnF4 both are ionic tetrahalides. So, okay. The next is SiCl4 is easily hydrolyzed. The answer is yes. This is a correct statement. I just told you. Only carbon tetrachloride. See, I explained here. Only carbon tetrachloride do not react with water because it do not have d orbitals. But the rest of them have d orbitals, right? Silicon, germanium, tin and lead have d orbitals. They will react with water and they will get hydrolyzed by water because they have d orbitals. We just discussed this thing. So answer to this is also yes. Okay? Now next 2019 PYQ. Which of the following species is not stable? Which is not stable? We just discussed this thing. Which is not stable? See, this is a question. This question is made from a question given in your NCERT, right? Who can answer this? Who can answer this? Clear vision? Very good, very good, very good. Clear to very, very good. Should I just move a little bit this side? Who can answer this? Is not stable. Which of these species? Answer B I have received by Khushi. By B3 has also given me answer B. Okay. C for Capto, I understood. Now, Ovais Raja, Somasani, and Karthik and Kavya, everybody has given me the correct answer. SiCl6 2 minus is not a stable species. Otherwise, all the others are stable species. So you can again look at the stable species right now. Okay? All the others are stable, only this is not stable. Now we're going to study about the anomalous behavior of carbon. As we've discussed, this is the another thing we're going to discuss in each of the group, which is the first element, right? The first element of every group, the first element of every block is shows some kind of anomalous properties, different properties other than the rest of the group. Why? Because the first element always is the smallest element, right? It has the smallest size. Okay? What are the reasons? Because it has the smallest size. If it has the smallest size, therefore it will have the high ionization energy as well, right? So this is the second reason. The third reason is high ionization energy. It also has high electronegativity, right? This is the third reason. The fourth reason is it has small size, high ionization energy, high electronegativity, and the fourth reason is I just discussed, it has no d orbitals. Remember this thing, it has no d orbitals, right? For this reason, your carbon will show anomalous properties, which is different properties other than the rest of the group 14. Okay? And what are those different properties? The different properties for carbon is that the maximum covalency that carbon will show will be of 4. Hai. Covalency means number of bonds. Remember this term. Covalency means how many bonds can it form. So carbon can form a maximum of 4 bonds. Okay? But the other groups, bacha, they can form more than 4 bonds. As we have seen, they can form even 6 bonds, right? They can form more than 4 bonds, but carbon can only form 4 bonds, right? And in carbon, this is the first point that we discussed. The second point is, bacha, the carbon actually forms p-pi multiple bonds. What does it form? It forms p-pi multiple bonds. What does it mean? For example, we all know that carbon can form multiple bonds with either itself, C double bond C, C triple bond C, right? Or with other more electronegative elements. For example, with oxygen. For example, with oxygen it can form triple bond. For example, with nitrogen it can form triple bond, right? For example, so these kind of bonds it can form. Okay, so carbon forms p-pi multiple bonds, but all the other members actually form d-pi multiple bonds, d-pi or d-pi multiple bonds. Okay, multiple bonds they form. Okay, so for example, the multiple bonds formed by carbon are with carbon itself or with other second period elements. For example, oxygen, nitrogen, right? These all belong to the second period. And in the second period, they only have p orbitals. They do not have any d orbitals. But from the third period onwards, d orbitals are introduced. Hence, from the third period, this is the third period, right? These belong to the third period. So from the third period onwards, what happened? They form d-pi and d-pi multiple bonds. What are the example of them? The examples are, for example, SiF5 minus is formed. Okay, I'm writing these examples, very crucial. Please write them down. Okay, or SiF6 2 minus that we just saw. Okay, or germanium chlorine 6 2 minus is formed. Okay, or bacha. Okay, everybody can see this. Everybody can see this. Now the next is germanium tin hydroxide. What is that? Tin OH6 is formed like this 2 minus. Okay, so these are some kinds of see, can you see in all of these cases what is happening? More than 4 bonds are forming, and all these bonds, all these multiple bonds or the single bonds are actually d-pi and d-pi bonds. There is no p-pi below carbon. Only carbon has the tendency, only the second period has the tendency to form p-pi multiple bonds. Okay, everybody understood this? Everybody understood this? So these are the, ma'am, please show the structure of p pi p pi. Beta, p pi p pi is nothing. For example, this is the carbon molecule. Carbon has a p orbital in it. Everybody is familiar with the p orbital, right? So carbon has a p orbital, है ना? The other carbon will always also have a p orbital. Now, in the chemical bonding, you have learnt about how the pi bonds are formed. How are the pi bonds formed? When the p orbitals are parallel to each other, right? Then there is a lateral bonding formed between them. So this carbon has a p orbital, this carbon has a p orbital, and both of those p orbitals are parallel to each other, and a lateral kind of bonding is formed. That bonding is called p pi bond. What is p pi? Beta, pi bond is what? Pi bond is any multiple bond. Double bond is also a pi bond, and a triple bond is also a pi bond, right? Pi is what? Any multiple bond is called pi bond. First of all, understand this, है ना? Any multiple bond is called pi bond, and because p orbitals are being used to form these pi bonds, to form the double bond, to form the triple bond, so therefore this is called p pi bond. But if d orbitals are used to form the multiple bonds, the double bond or the triple bond, then they are called d pi or the d pi p pi bonds. Everybody understood? Everybody understood? This is a very basic concept which you learn in chemical bonding. ठीक है? ठीक है? Shall I move on to the next slide? Next slide. This is again the periodic table is for you. I've attached it here just to tell you कि all the second period. This is the second period from lithium, beryllium, है ना? Boron, carbon, nitrogen, oxygen, fluorine, neon. This all. Can you see? This is the second period. So in second period, what happens? There is only and only p orbital. That is why they form only p pi bonds. But from the third period onwards till the seventh period, the d orbitals are present. Hence they form d pi or the d pi p pi bonds. Remember this thing. Second period only has p orbitals in it. Do not have any tendency of d orbitals in it. ठीक है? ठीक है? Next is catenation property. Everybody is very aware in organic chemistry. What do? We make use of the catenation property of carbon, right? Carbon forms so many compounds with itself, है ना? Carbon forms so many long chain, 100 carbon, 1000 carbon, 10,000 carbon polymers are formed, right? Lakh tons and tons of polymers are formed. So what is happening? The carbon is forming, the tendency of carbon to form a bond with itself, and that too long bonds, right? That too many atoms can attach together. That property is called catenation. I do not have to tell you again and again. You've learned it so much in your organic chemistry. Okay, so for example, the carbon, what happens with carbon in catenation? The carbon can form even rings, right? It can form rings, it can form chains, right? It can form rings, chains with itself. Such property is called catenation property. Now, what is in carbon that guarantees is this property, right? There's so many elements in the 40 group. Why is only carbon able to show so much catenation, right? Because bacha, the carbon, the CC bond length, the CC bond energy is very high, right? Therefore, it is very hard to break them. Why? Because carbon are smaller atoms. Hence, they get attached to each other with strong bond energy. They have very high bond energy. Hence, they can form too many catenation products. And as we go down the group, what is happening? As we go down the group, the bond energy actually decreases. Decreases. Why does it happen? Because the size of the atom is increasing. As the size increases, the bond length will also increase, and we know longer bond lengths are weak bond lengths, smaller bond lengths are strong bond lengths. Hence, as we go down, the size increases, therefore the bond energy also decreases. Now you should know the catenation trend. What is the trend followed for the catenation? What is the order for catenation? So, bacha, I am writing it here. Very important. This was again a JEE question this year in 2024 came. Okay? The catenation property is carbon shows the maximum catenation. Then silicon also shows somewhat catenation, like 8 to 10 8 to 10 silicon atoms can join together and show catenation properties. Okay, and then even germanium shows little bit. Then germanium and tin actually shows similar kind of catenation property. Okay, remember this trend. Carbon shows maximum, then silicon, then germanium and tin shows similar, and your PB shows no catenation at all. Remember this thing. PB shows no catenation at all. Catenation is what? The property to form bonds, rings, chains with itself, many longer bonds. Why is it possible? Because carbon-carbon bond length. What happens? The carbon-carbon bond length is small, hence it has higher bond energy, hence it can form very much catenation products. ठीक है? ठीक है? Next is, we have discussed the catenation property. Next is, bacha, allotropes of carbon. I know that the compounds of carbon have been removed from your syllabus, but just to be on the safer side, I'm going to discuss a few things which have the chances to being asked. What is allotropes? Because allotropes, bacha, can be included in the physical property of carbon, right? What is allotrope? Once again, allotropes are the physical form of carbons. Remember this thing. Allotropes are the physical forms of carbon, है ना? Because what happens, the major allotropes of carbon that you know are graphite, diamond, right? And what is happening in graphite and diamond? They're all formed of just carbon only, right? Carbon and graphite are just carbon molecules, but their arrangement of the atom is different. Hence, the properties of these elements are different, right? Otherwise, they're made up of just pure carbon only. Only that the bonding in them is different. Okay? So why does carbon show allotropy? Bacha, due to the property of catenation and the p-pi bond formation, carbon is able to show allotropic form. So this is the reason, very important, can be asked in your exam, why carbon shows allotropy? Because of the property of catenation and because it can form p-pi bonds. What is p-pi bonds? I just explained to you. Now there are two types of allotropes of carbon, crystalline and amorphous. Okay? Crystalline means what? Where all the bond atoms are arranged very in an order. Okay? For example, crystalline means where the crystal structure has a very ordered structure. Okay? Similarly, what are amorphous atoms, bacha? The amorphous are where the crystal atoms are not arranged in a ordered way. That is it. That's it. You need to know, because solid state has been eliminated from your syllabus, right? You do not need to know anything more, because there used to be solid state chapter again in chemistry where you learn so much about what is crystalline and what are amorphous compounds. But right now, this definition is enough. In crystalline, what happens? Crystalline, there are three kinds of allotropes: diamond, graphite and fullerene. In amorphous, there are again three kinds: carbon black, coke and charcoal. Okay, there are three kinds again: carbon black, coke and charcoal. Okay. Okay. Now next, let's move on to the next. Now comparison of allotropes. But this is the structure of fullerene. Remember this thing, fullerene. Okay, all these balls that you are seeing, right? All these balls that you are seeing, all these balls are actually what? Are actually carbons attached together. Similarly, this is again a carbon structure, but this is graphite structure, right? And this is again a carbon allotrope, but this is diamond allotrope. Can you see that in all these structures are made up of carbon, just pure carbon, but their bonding is different with each other. Okay? That's why they're giving rise to different kind of physical forms, different kind of allotropes which have different properties, different everything. Okay? Now let us look at the comparison of these allotropes. In diamond, it is a sp3 hybridized carbon. Sp3 means what? It forms four bonds, right? Can you see? If this is the carbon, let me change pen color, I'll take red. If this is the center carbon, can you see this carbon is again attached to one carbon, two carbon, three carbon and four carbon. So every carbon in graphite is a tetrahedral structure attached to four more carbons, right? But graphite has a sp2 hybridized carbon. Okay? Graphite mein there is just sp2 hybridized. One carbon is attached to just 1, 2 and 3 atoms. Here the carbon was sp3 hybridized. Here the carbon is sp2 hybridized. ठीक है. In Buckminster fullerene, again the carbons are sp2 hybridized only. ठीक है. In diamond there are just sigma bonds present. Sigma is what? Any single carbon bond is called a sigma bond. ठीक है. In graphite there are both sigma and pi bonds, and in Buckminster also there are both sigma and pi bonds present. The bond length of diamond is 154 picometer, which is the average carbon-carbon bond length, right? Average carbon-carbon bond length. The bond length in graphite is a little bit less because it has a pi bond as well, and the bond length in Buckminster is even lesser. ठीक है. Diamond has a tetrahedral shape, obviously because it is sp3 hybridized. We know sp3 hybridized structures have a tetrahedral shape. Graphite has a hexagonal layer structure. Can you see that hexagons are made? Hexagons are what? 6 carbon atoms attached together. Hexagons are kept at below each other. है ना? The hexagon are stacked above and below each other, and they are layered, and they are present in a layered form. And the Buckminster fullerene has a soccer ball structure. Remember this thing. And the height, because we know that diamond is the hardest material, so its delta heat of formation is 1.9 kilojoule per mole. Delta heat of formation is almost zero, and it is 38.1 kilojoule per mole, even more stable. ठीक है. And which, if you get asked which is the most thermodynamically stable form of carbon, it is actually graphite. ठीक है. You don't need to get into much more details because it is never asked in your exam, but just in case if it gets asked, so I've told you each and everything about these, comparison of allotropes, everything we've discussed over here. ठीक है. Now next we are back to the NEET 2023 PYQ. Who can answer this question for me? Hi Ashwin. Hi Anirudh. Who can answer this question for me? Hanji. Match the list. Coke, diamond, fullerene, graphite. ठीक है. So this kind of question used to be asked in your NEET exam up till last year, but now because you have reduced syllabus now, so there are lesser chances of this kind of question being asked, because it's again a compound of carbon, you can say, right? We are talking about compounds which is not there in a course, but just in case, because this is again the allotrope of carbon, a physical form of carbon, so they have the higher chances to get asked. That's why I've included this PYQ here. So who can answer this? Graphite. Graphite is used as a what, bacha? As we know, diamond, all the carbon atoms are sp3 hybridized, right? I can match this. Very good. Shubham has already answered. See, for the B, the first option seems correct, right? Because the carbon has all sp3 hybridized. For fullerene, what? Fullerene, they have cage-like molecules, right? So fourth will come here. For graphite, it is used as a dry lubricant because it has a layered structure, right? Because due to the layered structure, due to the sp2 hybridized carbon, they are used as a dry lubricant. Okay? And therefore, coke is used as a very, very good reducing agent. The third option is correct for this. Again, this coke, bacha, is from your another chapter, which was metallurgy, again removed from your course. Okay? I cannot do anything. Most of these things are removed. Now, let's look at, see, from my side, the group 14 is complete. We have talked about all of its atomic properties, the ionic radius, the ionization energy trend, the density trend, the melting point trend, all the trends we've talked about. Then we've talked about all the possible chemical reactions with the oxygen, with water, with halogens, right? And we've talked about their properties, what will be acidic, what will be basic, what will be formed, what will not be formed, what will be hydrolyzed, what will not be hydrolyzed. So all the possible things we've discussed. Okay, right now I want you to know some important structures. These are the compounds given in the NCERT, but the compounds are, from a syllabus it is eliminated. Compounds of anything are eliminated, of all the groups. Only the trends will be asked, that is the new syllabus. But you should know these structures. Only the structures. We're not going to talk about any of the properties, any of the preparatory methods, any of the reactions, but we should know the structures, because the structures are again what? Structures are again a reaction between silicon and oxygen as only, right? So, bacha, this is the structure of SiO2. Can be asked in your exam. It was asked in the JEE main 2024 exam. That's why I'm repeatedly telling you. Even though even for the JEE students, bacha, the syllabus is the same, that is a reduced syllabus. You guys have the similar syllabus as the JEE guys. But again, this question was asked. What was asked? Like, what is the structure of SiO2, right? Then you should know. Many people what will write, because Si has only 2 oxygens attached to it. Hence, they will write some other form of structure, whatever they deem to be correct. But SiO2 actually has a tetrahedral structure. Can you see? One Si atom is connected to 4 other oxygen atoms. So, SiO2 has a tetrahedral structure. Remember this thing. SiO2 is a very, very important molecule. It is also called silicon dioxide, but it is also known as silicates, right? SiO2 is also known as silicates. Okay? And SiO2 has this structure, and each unit here, bacha, is called the SiO4 2 minus unit, which again has a tetrahedral structure, right? And the another structure you should know is the structure of the silicon. Silicon, what is happening? In this, with the silicon, 4 oxygen atoms were attached in SiO2, right? But I've replaced the 2 oxygen atoms with 2 methyl groups. I've done just this thing, right? When I do that, when I replace the 2 oxygen atoms with 2 methyl groups and form a polymer of it, with silicon I can make polymer. Can you see N is attached over here? It means N units of SiCH3 whole twice O whole twice units are added. It's called a polymer. This kind of compound is called a silicon, which is used to make again some kinds of polymers. So these are the compounds of silicon. But what you should know their structures. SiO2 has a tetrahedral structure. Even SiO4 2 minus also has a tetrahedral structure. SiO2 is a 3-dimensional structure of SiO2. Okay, everybody understood this? Beta, you can ask the doubts in, I will share the Telegram ID in the comment section. Okay, abhi I'm not sharing. After the session is over, I will share in the comment section my Telegram ID so that you can ask me doubts. Okay, pakka se I will do that. Okay, now NEET 2013 question. The basic structural unit of silicates. Silicates basic structural unit I just discussed. Who can answer this? Who can answer this? The silicates basic structural unit. Yes, bacha, those are van der Waals bonds. Yes, Ovice Raja, those are van der Waals bonds. Yes. NEET 2013 question. The basic structural unit of silicates. Also remember one thing that no answer this question. I'm not going to deviate you right now. I will tell you at the end of the lecture. Hanji, who can answer this? Who can answer this? The basic structural unit of silicates. This group 14 is over here. Now we're just doing the PYQs, and then we're going to do the group 15 today. Okay, group 15 today. I've received, Ovias has given me answer D. Kavya has given B. Shubham Polpar has given B. The correct answer, bacha, is D. SiO4 4 minus unit. The silicon was here. The oxygen was here, right? Remember the structure. Every oxygen had a negative charge on it, right? So, the structure is SiO4 4 minus is the correct answer. Okay? 2 1 silicon, 4 oxygen atoms are attached, and all the 4 oxygen atoms have 1 each negative charge on it. Hence, the answer is SiO4 4 minus. This is the unit of silicate. Okay? Now, next 2017 question. You are absolutely correct, oh guys. It is because of the inability of the Ns2 electrons of the valence shell to participate in bonding that. Who can answer this? I just told you that as we move down the group, what happens is stability of lower oxidation state increases and the higher oxidation state stability decreases. Why does it happen? Due to the inability of Ns2 electrons to participate, right? For example, for the group 14, the configuration is Ns2Np2, right? This is group 14 configuration, isn't it? Isn't it? Now, when the Ns2 electrons do not participate, this is itself is called the inert pair effect. The Ns2 electrons do not participate. है ना? So, which option do you see to be correct? Who can answer this question? What do you think is the correct option? Which one will act as a reducing agent? Which one will act as oxidizing agent? Again, writing down the elements of group 14 over here. First is carbon, silicon, germanium, tin, and lead. These are the elements in this order. Who can answer this question for me now? Who can answer this question for me now? I'm looking at the chat box once again. Ovai has given me the answer D. D. That Sn plus 2, he's saying, ma'am, Sn plus 2 will act as a reducing agent. Okay. He's saying Sn plus 2 wants to get oxidized to Sn plus 4, while Pb plus 4 will wants to get reduced to Pb plus 2. That's what you're saying. That's what you're saying, right? Reduce to, and here it will get oxidized, right? So therefore Sn plus 2, because here what happens, as we go down the group, the stability of plus 2 oxidation state is increasing. If the Pb is in plus 4 oxidation state, it will want to convert into plus 2. Remember this thing. Pb here is in plus 4, it wants to convert into plus 2 oxidation state. Therefore, it itself is getting reduced. Something which gets reduced is called the oxidizing agent. Hence, Pb plus 4 will act as an oxidizing agent. Okay? The Pb plus 4 is reducing, bacha. Here, there is... beta, your answer is wrong, Ovais. There is no oxidizing agent written over here. Is there oxidizing agent or reducing agent written? No. It is saying that Sn2 plus is reducing. है ना? So Sn2 plus is reducing while Pb plus 4. No. You are correct. Is reducing means what? It is a reducing agent and it is a oxidizing agent. No. You are correct. Therefore, Sn plus 2 will act as a reducing agent and the Pb plus 4 will act as a oxidizing agent. Hence, D option is correct. Reducing. matlab it is reducing something else. Agar if it was here ki Sn plus 2 reduced, then it would be wrong. But here right now it is correct. Correct. No, bacha, the answer is D only. Sn plus 2 is reducing in nature and Pb plus 4 is oxidizing in nature. Okay? I know that language is a little bit typical, but that's where they play, right? That's where they play. Just be very careful with the language. Even I got confused for a while. Okay? But this is correct. D option is correct. Okay? Now next, AIPMT 2007 question. Which of the following oxidation states, see, oxidation states question are so common, are the most characteristic for lead and tin? Lead is Pb, tin is Sn. Bataiye, who can answer me this question? For lead and tin respectively. Answer me. I'm looking at the chat box. Once again, AIPMT 2007 question. Very beautiful question. See, oxidation state question are so necessary to know. Every oxidation state is so crucial to know. Please answer me. I'm looking at the chat box once again. Okay, I've received two answers by Ovias and Dr. Apollo. So lead, you are saying that lead is most common, plus 2, and correct. Very good. A is the correct option. Lead's most common oxidation state is plus 2. And tin is plus 4. Correct. Very good. Very good. Okay, let us move forward. A, Shubham and Kavya all have answered a correct answer. Now we are moving towards the next group, which is 15th group. Are you ready? This group is very easy once again. 15th group is what? The nitrogen family is called the 15th group. It has another name which is called nicogens. Remember this thing. These are also called nicogens. This is their common name. Nitrogen family is the 15th group. 15th group means what? That its outermost configuration is NS2, NP3. Do you notice anything in its configuration? Can I write its configuration? For example, in the NS orbital, it has 2 electrons, right? In the NS orbital, it has 2 electrons. And in the NP orbital, it has 3 electrons. Can everybody look at the electronic configuration? Can you look how beautiful the electronic configuration is? That here they have a stable. Can you see that here in the p orbital the configuration is half filled, right? Half filled. And as we know that half filled and fully filled orbitals are actually stable orbitals, right? Therefore, Therefore बच्चा group 15 has somewhat stable electronic configuration. Everybody understand this? Does everyone understand this, that they have somewhat stable configuration because of their half filled p orbital and fully filled s orbital? Okay. The next thing that you should know about the nitrogen family is the first two elements, nitrogen and phosphorus, are your non-metals. Okay. The next two elements here are your metalloids. What are they? They are your metalloids, right? And the bismuth, only the last element, is actually a metal. So this is the basic idea of a 15 group. What is the electronic configuration? Their electronic configuration is half filled. Therefore, it is a little bit more stable. They are also called as nicogens. And in this group, there are non-metals, nitrogen and phosphorus, metalloids, arsenic and antimony. And bismuth is the metal. Okay? Everybody understood these points? These points are clear? Okay? Next is the occurrence. Bacha, in your NCERT, occurrence is so much important. Please pay attention because questions from occurrences will be there, especially after the reduced syllabus. Pay attention to those things which most of the students tend to ignore. They're like, I cannot even remember this after 2 days. Why should I even bother studying this? But please study this. Okay? Because this is going to make or break your rank. Okay? Number first, in the 15th group, what is the number first element? Nitrogen. Nitrogen comprises 78% by volume of the atmosphere. Everybody knows there is so much nitrogen everywhere, right? And in the Earth's crust, how is nitrogen? In the atmosphere, in the air, I know it is present as air and 78% is there. But in the Earth's crust, how it is present? It is present in form of your metal nitrates. For example, sodium nitrate, NaNO3, and its common name is chili saltpetre. Please pay attention to the common names, to the minerals, because these are the questions that they're going to pakka se pakka ask in NEET exam. Like, you can take my bet on it. Okay. The next is potassium nitrate, which name is Indian saltpetre. And how are they found anymore? So in the Earth's crust, they are found as nitrates. In our body also, nitrogen is formed in the form of proteins. It is found in plants and animals. Okay? The next element after nitrogen is phosphorus. How is phosphorus found? The phosphorus is found in the minerals of the apatite family, which is calcium apatite or the fluoroapatite, right? So they are found in these kind of apatites. Please remember the formula of these apatites, very very important. Okay? And which are the main components of the phosphate rocks? In our body, bacha, it is also present in animal and in plant matter also. Phosphorus is present in our bones. Phosphorus is present in living cells. Okay? The next is phosphoproteins are present in milk and eggs, which are very essential for our health, for good health, right? Next is arsenic, antimony and bismuth. The other three elements, they are found majorly as sulfide minerals. This is about the occurrence, very important topic. Okay? Next is the electronic configuration, which I already told you. The electronic configuration is ns2np3 kind. Okay? This is the electronic configuration, isn't it? Now what happens to the electronic configuration, bacha? Why am I showing electronic configuration? Just to let you know that in the arsenic first time the d orbital is introduced, and in the bismuth first time f orbital is introduced. Here d, here first time f orbitals are introduced, and these are the electronic configurations followed. Okay, this is the, and the trends of these group are very very simple. Okay, there are zero exceptions. In the 15th group is the easiest element. For example, what happens to the atomic radii when I go down the group? Okay, when I go down the group, what will happen? Nitrogen has only 2 shells, phosphorus has 1 2 3 shells, arsenic has 1 2 3 4 shells. So what is happening? As I'm going down the group, the number of shells are increasing, hence the radius should also increase. Okay, down the group, what should be the trend? So the similar trend is followed, that nitrogen has the smallest radii, then phosphorus, then arsenic, then antimony, and then your bismuth. Very easy trends, very easy, extremely easy. No, zero exception trends are followed over here. Okay. Now what happens to the ionization energy? Ionization is what? For example, this is your metal atom. Now I want to take out electron from the outermost shell. to take out electron from the outermost shell, the energy required to take out electron from the outermost shell is called the ionization energy, right? Now, as I go down the group, the number of shells are increasing. Hence, the outermost shell is far away from the nucleus. Hence, that electron in the lowermost shell experiences the very minimum attraction forces. Hence, it is easier to remove the electron from that bigger element. Therefore, as we go down the group, what happens? As the size increases, ionization energy decreases. So similar trend is followed over here. The trend is similar. Similar is what? The nitrogen has the highest ionization energy, right? Then it is the phosphorus, then it is the arsenic, then it is the antimony, and then it is the bismuth. Similar trend is followed. Okay, there are no exceptions. But just one thing you have to know. If I want to ask you the ionization energy between group 14 and your group 15, which one will have the higher ionization energy? Who can answer this question? Who can answer this question? Between group 14 and group 15, which one will have the higher ionization energy? Hanji, who can answer this? Bacha, as I'm going from group 14 to group 15, the size is decreasing. And also, group 15 has a stable configuration, right? I just told you it is ns2np3. The p orbital is half filled. Therefore, it has somewhat more stable configuration. Hence, the ionization energy of group 15 is much more than your group 14. Okay, this is another thing that you should know. Okay. Now, next thing that we're going to talk about is the electronegativity. We've talked about the ionization energy. Now, the electronegativity we are going to talk about. Now, I told you that here bismuth was a metal, right? And nitrogen and phosphorus were your non-metals, right? So, what is happening to the electronegativity? As I am going down, because something which is metal shows electropositive character, not the electronegative character. So when I'm going down the group, what is happening? The metallic nature is actually increasing, right? The metallic nature is increasing when I'm going down the group. Hence, the electronegativity order is exactly very similar. It is what? Nitrogen is most electronegative, then your phosphorus, then your arsenic, then is your antimony. And but the antimony and bismuth have somewhat similar electronegativity. Just remember this thing. Okay? So this is one kind of exceptions that you can believe, that antimony and bismuth have similar electronegativity. This is the electronegativity order that is followed. Okay? Yes. Yes. Next is physical properties. We have talked about all of the atomic properties. What are they? What is the trend in radius? What is the trend in ionization energy? What is the trend in electronegativity? Right? All of these things. What is the trend of electronic configuration? We've talked about all of these things. Now we're talking about their physical properties. What are their physical properties? Right? So, bacha, you should know ki all elements of group 15. Group 15 we're talking about. Okay, we're talking about just group 15 elements. So here all the elements show polyatomic nature. Polyatomic nature, but there is again an exception. Exception is very common except your nitrogen. Why? Because nitrogen is found only as N2 molecule, right? In your air, nitrogen is found as how? Because nitrogen is not a polyatomic, it is a diatomic molecule. Diatomic means what? That nitrogen is found as N2 molecule, right? But except nitrogen, all others are found as polyatomic. For example, bacha, phosphorus is found as a P4 molecule or even a P8, P6 molecule, right? So most common is a P4 molecule in which your phosphorus is found. Okay? So these are these kind of polyatomic molecules. Okay? And also except nitrogen, one more thing, except nitrogen, all others show allotropy. Remember these things, very important things. What does it mean? What does it mean by that? Allotropy means different physical forms. For example, carbon shows allotropy. Carbon is diamond is also carbon. Graphite is also carbon. Buckminster fullerene is also carbon, but they're all different substances, right? This is diamond that I'm wearing here, but this is carbon again. The pencil with which you write in your exam, the pencil is graphite, which is again carbon, but very different from diamond, right? But again, these are what? Physical forms of carbon. Similarly, there are various physical forms of phosphorus, arsenic, antimony, bismuth present except nitrogen. All others show allotropy. ठीक है? ठीक है? And बच्चा, nitrogen is a gas, right? All others are solid. All others are solid. ठीक है? So these are some of the major क्या बोलते हैं, major things or minor things you can say, but very crucial from exam point of view, कि all others are polyatomic in nature, only nitrogen is diatomic. Except nitrogen, all others show allotropy. Only nitrogen is a gas and all others are solid in nature. So these are some of the physical properties that you should know about. ठीक है? Everybody understood this? ठीक है? Very good. Next, we're going to talk about physical properties. We're done. We're going to talk about the chemical properties. Now we're going to talk about the oxidation state. Right? Again, what? Let's look at the electronic configuration once again. The electronic configuration is NS2NP3. Right? Now, what can be their common oxidation states? Now, as you can see, to become a stable structure, to gain noble gas electronic configuration, what it can do? It can either number first gain 3 electrons, right? If it gains 3 electrons, then it becomes NS2NP6, right? So here the oxidation state becomes -3. Okay? The other process that it can do is give away these 3 electrons, right? If it gives away these 3 electrons, it lose 3 electrons. 3 electrons, then its configuration will become NS2, again a helium gas electronic configuration. So its oxidation state is +3 here. Now, what is the other possibility that it loses? All of these, 3 plus 2, 5 electrons. So if it loses, the other possibility is lose 5 electrons. Hence, its electronic configuration becomes a noble gas, hence its oxidation state becomes +5. So can you see what are the 3 most common oxidation states possible? Therefore, -3, +3 and +5 are the 3 most common oxidation states possible for this group. Very easy funda to understand, right? So I am writing over here common oxidation state. What are those? Those are -3, +3 and +5. So group 14, these are the 3 most common oxidation state. Now another thing that you have to understand, as I am going down the group, what happens? As I am going down the group, I know the stability, I am writing it here. As I am going down the group, stability of what decreases of -3 and +5 both decreases. Remember this thing. Stability of -3 and +5 decreases while that of +3 increases. Okay? So as you're going down the group, this is the trend followed. Remember this thing. Okay? Okay? The bismuth doesn't form. I'm writing major points over here. Bismuth bacha doesn't show -3 oxidation state. Why? Because bismuth is a metal and metals only ever show positive oxidation states, right? So bismuth bacha do not form, do not show -3 oxidation state. Very, very first important point. If somebody asks you, then bismuth doesn't show -3 oxidation state. Okay? And is bismuth 5 present? So, bacha, only in one condition bismuth 5 is present, which is BIF5. That is it. Only bismuth 5. Okay? Because as we go down the group, +5 oxidation state decreases. But BIF5 is one element which is formed. Okay? It is the only +5 element which is formed. Okay? Now we are going to talk about the other elements. For example, nitrogen. What oxidation states nitrogen shows? So, bacha, nitrogen shows all oxidation states from +1 to +2 to +3 +3 to +4 to +5 and also -3. So nitrogen shows these many oxidation states in which we know that +3, +5 and -3 are the common. So along with +3, +5 and -3, it also shows +1, +2, +4 oxidation state. So nitrogen shows these many oxidation states. Please remember, and with which elements it shows so many oxidation states? With mostly oxygen. With oxygen, it shows +1, +2 and +4 oxidation state. Okay? The next atom that we're going to talk about is phosphorus. So along with the common oxidation state, which is -3, +3 and +5, it also shows +1 and +4 oxidation state. Remember this thing. Phosphorus shows +1 and +4 with oxoacids. What are oxoacids? I will let you know. We will learn about every oxoacid in detail right now. Okay? Now, can you see that nitrogen here can show so many oxidation states? So, whatever element, no matter nitrogen, phosphorus, whatever, if any element has the capacity to show a minimum of 3 oxidation states. ठीक है, यहाँ पे I am writing if any element has the capability to show minimum 3 oxidation states. Remember this thing. Then it can show disproportionation reaction. Where do you learn first about disproportionation? When you learn your redox reaction. These kinds of reactions are favorite for your examiner. Remember this thing. Disproportionation reactions are favorite. Now, which element will show disproportionation? Which number first condition is that element should at least show a minimum of, it can show maximum how many? It can show 5, 6, 7, 8 kinds of oxidation states, but the minimum it should show 3 oxidation states minimum. ठीक है? ठीक है? Now, bacha, what happens? For example, if nitrogen, for example, I'm going to show you this example. HNO2 disproportionates to form HNO3 plus H2O plus 2NO. Okay? This is the disproportionation reaction. This is a disproportionation reaction happening. So what is the oxidation state of nitrogen over here? The oxygen, here nitrogen is in +2 oxidation state. Okay? This nitrogen is getting converted into +3 oxidation state over here. And here, sorry. I just wrote wrong. Okay, one second. Here it is not in +3, it is actually +3 oxidation state, it is +5 oxidation state. Here it is +2 oxidation state. Now what is happening to this nitrogen? Can you see that this +3 is getting oxidized to +5? Can you see? The same nitrogen which was in the reactant side, in the product side, we're getting an oxidized nitrogen. From +3 it is becoming +5. Similarly, the same nitrogen from the +3 it is becoming +2, it is getting reduced over here. So can you see, in the same reaction, the same nitrogen is getting oxidized as well as reduced in the same reaction. These kinds of reactions, bacha, are called as disproportionation reactions. Remember this thing. When the same atom undergoes reduction and oxidation in the same reaction, okay, those kind of reactions are called disproportionation reaction. Everybody understood? Yeah, easy. ठीक है, very good. If you're finding it easy, that's extremely well. ठीक है, now we have discussed everything about the oxidation state, I guess. Correct, we've discussed everything. Now we're going to discuss about the anomalous properties. Again, I told you that every first element of any group will have a different property than the rest of the elements. Why? The reasons remain the same. The reasons are because it has a small size. The reasons are same for every element. It has a high ionization energy. It has a high electronegativity, and also it has no d orbitals. Okay? This is the reason why it shows anomalous properties. Is this thing clear to everybody? Ma'am, what makes half and fulfilled orbitals stable? But it actually depends on the stabilization energy. Okay, this thing actually you don't have to study that much. So what happens? Ovice has asked me कि why half-filled and fully filled orbitals are stable. For example, I'm going to tell you one example. So this is a half-filled orbital like this. The p orbital here is half-filled. Okay? Right now I'm going a little sidetrack right now just to answer your question. So half-filled orbital bacha has this electron which is in this orbital now has the possibility that it can go and shift in this orbital, and this can go and shift in this orbital, right? So this electron can go shift here and can go shift here as well. Okay, now let us look at the other electron. Now again this electron also has the same capability that this electron can either shift to this orbital or it can either shift to this orbital, right? Because these electrons are not stable, they keep moving, they keep jumping around these orbitals, right? Similarly, the next this electron again has the capacity to jump either in this orbital or in this orbital. Okay, so what is happening when the electrons are half filled or fully filled? This is called stabilization energy. So this stabilization energy increases in two cases. Number first, if the electrons are half filled or when the electrons are fully filled. Okay, so this is the reason, and these reasons are basically bacha quantum reasons which you do not have to delve into, which you do not, because this is a topic of very higher class. I also learned it in my master's degree. They do not even teach you in your bachelor's degree. Okay, they teach you in masters. If you go and specialize in some subject, that's when they teach you quantum and what are these energies, what happens. Actually this is just a little smaller part of it, smaller picture of it. What actually happens is beyond your knowledge right now. Okay, you just have to remember that half filled and fully filled are stable. That is it. No other question will ever be asked to you at this level. Okay? Yes, but the exchange energy, stabilization energy, it is related to the exchange energy and stabilization. Correct. Timothy has given the absolute correct name. Half filled is also called stable. But half filled is very stable. Half filled and fully filled are stable configurations, right? Right? Half filled and fully filled are stable configurations. You learn this in the atomic chapter. What is that chapter? Structure of atom chapter. है ना? Structure of atoms you read in that. ठीक है? Now these are the reasons, four reasons why nitrogen shows anomalous properties. These are the four reasons. You must be clear with them because we're mentioning these reasons time and again with every element. Now what happens due to these reasons? Once again, nitrogen bacha forms your p-pi bonding, right? ठीक है, बचा नाइट्रोजन फॉर्म p-pi bonding with either itself, ठीक है, itself p-pi bonding with itself or with more electronegative atoms. ठीक है, itself, how does it? p-pi is nothing. p-pi means what? Any multiple bond is called a p-pi bond. For example, the nitrogen forms a bond with itself. This nitrogen, ठीक है, the nitrogen N2 molecule has a triple bond. What is this bond called? These bonds are called p-pi bonds, right? Similarly, nitrogen can form double bond with oxygen. ठीक है, similarly, nitrogen can even form bonds with carbon also. It can form like this, है ना? So with the similar p block elements or with higher electronegative elements, it can form p-pi bonds which are stronger bonds. But the rest of the elements from phosphorus to bismuth, they can only form d-pi p-pi or p-pi or d-pi bonds. ठीक है, d-pi bonds which are bacha not that strong. These are stronger bonds. p-pi bonds are stronger bonds. Remember this thing. ठीक है, this is one of the property about the multiple bondings that I taught you. The next bonding that you should know about the nitrogen molecule, I just told you. Nitrogen molecule has a triple bond in it, right? So bacha, the N2 gas, you will ask me, ma'am, there is so much nitrogen gas in the atmosphere, hence still there are no reactions happening. You are telling me 78% in the air is just nitrogen, but I see no reactions happening in the air. Why? Because bacha, nitrogen is a inert gas. Inert means it do not show much reactions. Why? Because can you see, this is the structure of nitrogen. Nitrogens are small molecules and they are bond to each other through triple bond. Hence, these are small molecules bond to each other through triple bond. So these are very, very strong bonds. These are very, very strong bonds, hence have very, very high bond energy. Because they have very, very high bond energy, it is very, very difficult to break them. They do not break, hence they do not show reactions easily. You have to increase temperature so much, increase the pressure so much, only then they can show some kind of reactions. Otherwise, naturally, they do not show any reaction. So this was about the multiple bonds. But what happens with the single bonds? With the single bonds, there is a actually different kind of case. For example, the nitrogen-nitrogen single bond bacha is actually a weak bond. Remember this thing. The multiple bond is stronger bond than rest of the elements. But the single bond is actually weak bond. Why? Because I again told you nitrogen is a highly electronegative element, right? For electronegative means, and if it is a small element, highly electronegative element, if another nitrogen try to approach it, then these will cause repulsion in itself, because these are small molecules, right? And you're trying to bring two smaller molecules which are highly electronegative, too much charge density on them together, so they will cause repulsion. Hence, this nitrogen-nitrogen single bond, which is actually a weak bond. Remember this thing. Okay? Is weaker bond. So this bond is weak bond than your PP, phosphorus single bond. Very, very important point. This is a weaker bond than your small. Why? Because similarly I told you what is the reason behind it, because these are smaller atoms, hence they face so much of repulsion. Is this thing clear to everybody? Is this thing clear? Is this thing clear? ठीक है. Next is, we have discussed the anomalous properties. Next is reactivity with hydrogen. We have discussed everything. Now we are going to discuss the reactivities. We have discussed the oxidation state. We have discussed the, what are the oxidation state? You must remember the three common oxidation states, right? Now we are back to the chemical properties. First we will discuss with hydrogen, then oxygen, its chemical properties, then the compounds with halogens. And then this chapter will complete. ठीक है. Now reactivity with hydrogen. What are the common oxidation state? The common oxidation state was +3 and +5, isn't it? +3 and +5 are the common oxidation state. But with hydrogen, it generally forms the +3 hydrides. है ना? It generally forms EH3 types of hydrides. Remember this thing. With hydrogen, it generally forms trihydrides. ठीक है? Trihydrides is formed, hence the oxidation state with hydride shown is the -3 oxidation state. What oxidation state is shown? The -3 oxidation state is shown with the hydride. Okay? Here the element will be in -3 oxidation state because the hydrogen will be in +1 oxidation state, because nitrogen is more electronegative than hydrogen. Hence what is happening? Hence what is happening? Your group 15 elements are getting the negative oxidation state. Now, the very, very important trends we are going to discuss, which are asked in the exam, the bond angle trend. For example, this will form NH3, this will form PH3, this will form ASH3, this will form SBH3 with hydrogen, this will form BiH3 with hydrogen. ठीक है, and their bond angles are in this order बच्चा. NH3 has the highest bond angle because this is the most electronegative element. ठीक है, then will be your PH3, then will be your arsenic hydride, then will be your antimony hydride, and then will be your bismuth hydride. Remember these things. This is a trend for the bond angles. Is everybody understanding that? Everybody understanding that? ठीक है. Now next bond and trend is with the thermal stability. What is stability? Bacha, thermal stability means what? Which of the hydride will be most stable? Now understand one thing. Hydrogen is the smallest molecule, right? So because hydrogen is a small molecule, so it will form stronger bonds with another small molecule, right? So here, as I'm going down the group, the size is increasing, right? So therefore, the bond length with hydrogen will also increase. So therefore, a smaller atom forms stable bonds with another smaller atoms. Remember this thing, because hydrogen is smaller, it will form a stable atom with another smaller atom. Hence the trend of this thermal stability will be like this. NH3, ammonia is the most stable hydride, then your PH3, then your arsenic hydride, then your antimony hydride, and then your bismuth hydride. Remember this thing. Okay? Smaller atoms form stronger bonds with another smaller atoms. The next is the reducing character. What is meant by reducing? Anything which gives away hydrogen easily, right? Anything which gives away hydrogen easily will show the most reducing character, right? This is one of the definition of reducing agents, na, which gives away hydrogen easily. So which one will give away hydrogen? Where the bond stability is the least. So it will be the opposite of the thermal stability. Simple, है ना? Because here the bond is strongest, so it will not give away the hydrogen easily. But in bismuth hydride, the bond is not that stable, hence the hydrogen can go away easily. Hence the order of reducing character will be ulta, opposite order, that NH3 will be the least reducing, then your PH3, then your arsenic hydride, then your antimony hydride, and then your bismuth hydride. Is everybody understanding this thing? Is everybody understanding this thing? ठीक है? Next is the basic character, bacha. The basic character that we are going to. Basic means what? The ability to donate electrons. Basic character means what? The nitrogen has a lone pair on it. The phosphorus has a lone pair on it. Right? The lone pair, the basic character means the capacity to donate its electrons. So, bacha, basic character is actually NH3 has the most basic character. Then your PH3, then your arsenic hydride, then your antimony hydride, and then your bismuth hydride. ठीक है? Everybody is understanding this thing? ठीक है? ठीक है? ठीक है? Next we're talking about solubility. Solubility means what? We're always discussing solubility in water. ठीक है? Now बच्चा, nitrogen, as you know, hydrogen bond. What is hydrogen bonding? But a hydrogen bond is on every time. Remember this simple little funda. You will never get confused in any of the exams. Hydrogen bond is formed between hydrogen and oxygen, fluorine, and nitrogen. That is it. That is it. No other element forms hydrogen bond. Only oxygen, fluorine, and nitrogen forms hydrogen bond. No other element will ever in the entire life will form hydrogen bonding. Okay? So as you can see, only because nitrogen is present in the group 15, therefore NH3 can form H bond with water. H bond with water. Okay? Hence it is soluble in water. Okay? Hence NH3 bacha is soluble in water. Remember this thing. NH3 is soluble in water. Rest of the species are not soluble. Only NH3 is soluble. Rest hydrides are insoluble because they cannot form hydrogen bonding. Next is the boiling point. So what is the boiling point? Boiling point depends upon the size. As the size increases, the van der Waals forces will increase, hence the boiling point will increase. So therefore the boiling point follows this order. NH3. ठीक है? NH3 बच्चा, but NH3 will not have the lowest boiling point. Why? Because NH3 forms the hydrogen bondings. Correct? So the lowest boiling point will be of PH3. Okay? Then will be your arsenic hydride. And then will come your ammonia. Remember this thing. Then it will be your antimony hydride, and then it will be your bismuth hydride. Can you see that there is an exception of ammonia over here? Why does the boiling point of ammonia increases even though it is smaller in size? Its boiling point increases because it forms hydrogen bonding once again. So due to the hydrogen bonding which is difficult to break, therefore the boiling point of ammonia increases a little bit. Okay? And what is the melting point? Again, melting point follows this order. PH3 has the lowest melting point, then your arsenic hydride, then your antimony hydride, and your ammonia has the highest melting point. Remember this thing. Ammonia has the highest melting point. This is the melting point order followed in your NCERT textbook. These are the trends which I made from the NCERT textbook. In the NCERT, there are just values given, right? From that values, you need to take out trends. So I have given, I'm spoon feeding you right now. If you have these notes with you, which you will get in the Telegram channel today itself, right, then your Aadha काम will become super, super easy. Super, super easy. Okay? Next is this question, very, very important. pH3 has a lower boiling point than NH3. Why? Who can answer this? I just told you the concept. Why pH3 has a lower boiling point than ammonia? Why does the boiling point of ammonia increases even though it has a smaller size? Why does it boiling point increase? Why does it boiling point increase? Who can answer this question for me? I am looking at the chat box once again. Yes. Also, bacha, when you are learning from me, you should continuously ask me questions. Okay? I am here to answer your questions. Hai? And you should ask me, even if you have silly pilly doubt, ma'am, why did it happen? Why does it happen? Be interactive. That's how, even if you are asking questions, you will also stay awake the entire lecture. And I will also know that you're learning from me. Just ask me any question, any random question. If you are so less in number right now who are here, then it's only easier for me to just identify a question and answer it. I have no option but to answer your question, right? And even if after watching the session you realize I didn't understand this topic, then comment. Let me know in the comment section. Then again, next time when we meet, or even in the Telegram channel, we can connect and solve your doubts, because bacha, these are the last 2 very precious months, correct? Please make use of it. Do not get distracted by anything else. H bonding, I've already got the answer from Archit and Shubham. Both have answered yes, bacha, because in NH3 what happens? H bonding happens. Due to the H bonding are difficult to break the strong bonds, hence they have a higher boiling point than pH3. Correct. Next, reactivity towards oxygen we're talking about. We're talking about the reactivity towards oxygen. Okay. Now, if I react these things, bacha, with oxygen, what would happen? Again, you should know their most common oxidation states are +3 and +5. Here, I am not writing -3. Why? Because oxygen is more electronegative than nitrogen, right? Therefore, the oxygen will get the negative oxidation state. है ना? Nitrogen will get the positive oxidation state. Hence, if group 15 reacts with oxygen, there are possibilities to form two kinds of oxides. Number first oxides is the kind E2O3 and E2O5, right? Here the element is in +3 oxidation state. Here the element is in +5 oxidation state, correct? So these kind of oxides can be formed, which is E2O3 and E2O5 oxides. Okay? Now there are certain things that you must know about the oxides. That is, as oxidation state of the oxides, correct? As the oxidation state of the oxide increases, I again and again tell you, as the oxidation state increases, and but just so does what happens? As the oxidation state is increasing, so does the acidic nature of the oxide. So does the acidic nature also increases. ठीक है? Understood this point? And I told you that as I move down the group, now based on this simple observation, if the oxidation state is increasing, the acidic nature of the oxide increases. But I told you, as we go down the group, what is happening? +3 oxidation state stability increases, while the +5 oxidation state stability decreases. So what will happen to the acidic nature of oxide? Now, as the higher oxide is becoming less stable while we are going down the group, therefore, based on these two observations, therefore, what is happening? Therefore, acidic nature decreases down the group. Everybody agrees with me on this point, है ना? If I'm going down the group, the higher oxidation state is becoming unstable. Therefore, the acidic character will also become less. So acidic nature decreases as you go down the group. These 2 points should be very clear to everybody. Okay? Now we're talking about the E2O3 oxides. E2O3 oxides. Okay? Who all show E2O3? Nitrogen and phosphorus, because these are the elements which can show the most +5 oxidation state. Okay, the E2O3 of nitrogen and phosphorus are acidic in nature. Remember this thing. Are acidic in nature, and similarly E2O3 kinds of oxide for arsenic, antimony and bismuth bacha are what? The antimony and arsenic and antimony are amphoteric oxide, right? And the bismuth bacha is a basic oxide. Remember this thing. Okay? This is what I told you, the E2O3. E2O3 means what? The N2O3, right? Or the P2O3. These two oxides are acidic in nature. That's what I told you, right? Similarly, arsenic, As2O3, and your Sb2O3 oxides are amphoteric in nature. Similarly, your Bi2O3 is actually basic in nature. Did everybody understand this? Did everyone understand this thing? You said bismuth can show +5 oxidation state. Beta, I told you that bismuth can show +5 oxidation state in just one case, which was BiF5. That is it. In no other cases it can show +5 oxidation. That is one exception which exists. Okay? And exceptions means what? That is the only case when the +5 oxidation state happens. Okay? Yes, bacha, it can show +5. Here also it is showing +5. But this is very, very unstable. The only stable +5 bismuth molecule that exists is actually BiF5 molecule. And that too we discussed in the halogens. The only +5 halogen that exists is the BiF5 with bismuth. Okay? With bismuth, BiCl5, BiBr5 does not exist. Only BiF5 exists. Okay? Clear, everybody? Now can we move forward? These things are clear, very important things. Now next thing I'm going to write to you. Now as I told you, the nitrogen can show various oxidations. That's the one thing we discussed, right? Nitrogen can show from -3 to +1 to +2 to +3 to +4 to +5 oxidations. It can show so many oxidation states, right? Now, due to that, we are going to look at all the oxides that all these oxidation states can make. For example, nitrogen can make this kind of oxide, N2O, and it can make NO oxide, it can make N2O3 oxide, it can make N2O, sorry, N2O I've already written, one second. Yes, it can form NO2 or N2O4. Okay? What is NO2, N2O4? But N2O4 is nothing but a dimer of NO2. Remember this thing. Okay? And the next is the N2O5 oxide. है ना? So these kind of oxides it can show, as we know, because oxygen is more electronegative than nitrogen. Hence, oxygen will get the negative charge. Hence, the -3 oxidation state goes away from the equation. है ना? -3, the nitrogen will not show with oxygen. With hydrogen, it will show -3 because hydrogen is less electronegative than nitrogen. Okay? Because oxygen here will get the -2 oxidation states of the nitrogen. So what is the oxidation state of nitrogen over here? The nitrogen is in +1 oxidation state. Here it is in +2 oxidation state, is in +3, right? Here it is in +4. Both the cases it is in +4 oxidation state. And here the nitrogen is in +5 oxidation state. Can you see that as I'm going here, the oxidation state of nitrogen is increasing? Hence, let's talk about the acidic character. I told you the higher oxidation state oxide is more acidic. Hence, N2O5 is the most acidic oxide than this, than this, than this. So, bacha, this is, bacha, the acidic character trend, acidic nature. So, acidic nature increases as the oxidation state is increasing. Remember this point. Okay, I want to tell you another important thing about the NO oxide. But the NO oxide is actually a odd electron species. Remember this thing. the NO oxide and also your NO2, both of these things. NO and NO2 both are odd electron species, but right now we're talking about NO. NO is actually a 11 electron species. Okay, what is its structure like, bacha? Its structure is somewhat like this. N double bond O. Here the oxygen has 2 lone pair of electrons. Here the nitrogen has 1 lone pair and 1 odd electron over here. Can you see? The nitrogen over here has 1 odd electron. Hence it makes it a 11 electron species, which is a kind of what? Odd electrons, right? 11 is an odd number, so it makes it a odd electron species. Hence, bacha, what happens? The NO gas is actually paramagnetic in gaseous form, okay? But in liquid or solid, it is diamagnetic. This is a very, very important observation about the NO molecule. NO molecule. Okay, somebody is asking me then why it is basic then. Beta, for what are you asking? Which is basic? Which is basic? Beta, nitrogen is not basic, na? What makes nitrogen basic? The NH3 molecule is basic because it has a lone pair of electron in it. Lone pair of electrons in it. That's why it is basic in nature. Nobody tells you कि N2O5 is basic in character. No, N2O5 is a acidic oxide. You need to know about the compounds. है ना? As the compound changes, so their characters also changes. Correct? Basic character, we were talking about their hydrides. Now the acidic character, we're talking about their oxides. There is a difference in the compounds. है ना? Difference in the compounds. ठीक है? Next that you are asking me is this for various valency of nitrogen? But these are the various oxidation states of nitrogen. Oxidation states and valencies are different things. ठीक है? ठीक है? Everybody understood? Now reactivity towards oxygen. I think I've told you most of the things with the oxygen part is over. Now the last reactivity with halogens I'm going to see. We've talked about the reactivity with hydrogens. We've formed hydrides. We've talked about the reactivity with oxygen. Now we're going to talk about the reactivity with halogens. Again, with halogens are even more electronegative than nitrogen. Hence the nitrogen will show two kinds of oxidation state, +3 and +5 oxidation state. Correct? Correct. Everybody is understanding this part. Now, bacha, with the what kind of halogens can it form? What kind of halides can it form? It can form two types of halides, EX3 as well as EX5 kind of halides. Okay? Tetrahalides and pentahalides will be formed. First of all, we're going to talk about the trihalides and pentahalides. Okay? So we're talking about the trihalides. So as I told you once again, as I'm moving down the group, what is happening here with bismuth? +3 is more stable with nitrogen. Which oxidation state is more stable? The higher oxidation state will be more stable, right? So, bacha, EX3, everything forms all stable trihalides. All are stable trihalides. All stable except your nitrogen. Remember this thing. Nitrogen do not form any stable trihalides. Only one is stable. Only NF3 is stable. Remember this thing. Only NF3 trihalide is stable. ठीक है? ठीक है? And बच्चा, all the trihalides are again covalent in nature. ठीक है? They are बच्चा what? They are covalent in nature except there's again one exception which is BIF3. Again, why is this not covalent? BIF3 is ionic again due to the Fion's rule. है ना? We discussed as the cation का size increases, bismuth is so large. Bismuth is here, is large. Fluorine is the smallest anion. So when the cation increases and the anion size is very, very small, then the kind of bonding between them will be ionic bonding. ठीक है? Due to the Fion's rule, BIF3 is ionic except all other trihalides are actually covalent in nature. And what is the shape of the trihalides? These are bacha pyramidal in shape. What kind of shape? Pyramidal in shape. Remember this thing. Pyramidal in shape. ठीक है? ठीक है? Pyramidal in shape. Next thing that we have understood, they are pyramidal in shape. And I don't think there's anything else to make you understand. Okay, next is bacha the pentahalides. We're going to talk about EX5 kind of halides. In the EX5 kind of halides, which do not form EX5, nitrogen do not form. Nitrogen do not form EX5. Why? Because nitrogen cannot form 5 bonds, right? Because it has no d orbital. So nitrogen cannot form the trihalides also and the pentahalides. Pentahalides, why? Because it do not have so many d orbitals. Therefore, nitrogen do not form pentahalides. And these pentahalides are again covalent, but these are more covalent than your trihalides. Why? Because here 5 bonds have to be formed. है ना? The 5 bonds will always be shared bonds and they will be more covalent than the 3 shared bonds. Okay? Everybody understood? Everybody understood? And what will be the structure of the pentahalide here? Bacha, the structure will be, okay, I'm going to teach you about the structure in the next thing that we're going to see. Here right now, let's talk about the basicity order. First of all, let's talk about the basicity order. What can be the basicity order, bacha, here? What can be the... Beta, what is that question? Nagendra is asking, ma'am, can you explain how hydrogen react with NH5? Beta, NH5 is what? What molecule are you talking about? What molecule? The molecules I taught you was NH3. Okay, with hydrogen, nitrogen was forming a hydride. Nitrogen here was in -3 oxidation state. Correct? There is no NH5 molecule. Okay, there is no existence of NH5. Now the basicity order. Basicity order again very important. NF3 is the least basic. Then your NCl3. Then your NBr3. Then your Ni3. So can you see, bacha? Ni3 is the most basic molecule, then your NBr3, then NCl3, then NF3. Remember this thing. Remember this thing. So we have discussed the basicity order. They act as Lewis base. What do they act as? They act as Lewis base. Okay? No, bacha, it does not exist. NH5, no, bacha, no. See, nitrogen cannot form 5 orbitals. The maximum oxidation states, see, nitrogen usually shows -3 and +3 oxidation states. Correct? +5 it cannot show because it does not have so many d orbitals. So it does not show +5 mostly oxidation. Mostly it does not show +5 oxidation state. Correct? But what am I saying? है ना? NH5 doesn't exist. Okay, next. Reactivity with halogens we have completed. Let me see if I told you each and everything. Okay, no. We haven't talked about the stability yet. Let's talk about the stability. Let's talk about the stability order. Stability order. Okay, so I'm writing here element with the EF5, and EF5 will be more stable than ECl5 will be more stable than EBr5 will be more stable than EI5. Okay, everybody understood this? Beta, it does not exist. We were talking about NH3. Okay, so Acho, NH5 does not exist. Did I write NH5 anywhere? I don't know me. It was a 3. If you saw 5 written over, it was 3, not 5. Okay, so these are the stability order that the fluorides, the pentafluorides are the most stable, then the chlorides and the bromides and the iodides. Remember this thing. And EF5 are not even formed. None pentaiodides are found. There are no pentaiodides found. Okay? With Br5 only and only phosphorus form EBr5. Correct? And the Cl5, who forms Cl5? Bacha, phosphorus, arsenic and antimony. And antimony forms ECl5. And the pentafluorides are formed by phosphorus, arsenic, antimony as well as your bismuth. Remember this thing. Okay? Phosphorus, arsenic, antimony, bismuth form pentafluorides. The pentachlorides are formed by just phosphorus, arsenic and antimony. Pentabromides are just formed by phosphorus, and pentaiodides are not at all formed. None of the pentaiodides are known in nature. The another thing that you should know is the structure of PCl5 molecule, bacha. PCl5, as I told you, it is a pentachloride. We have to form 5 bonds. Hence, you will say, ki ma'am, these 5 bonds are formed, hence they will be covalent in nature, will not be ionic. Otherwise, I have to give them 5 ionization energy. So that is true. This is a covalent molecule in the gaseous state. Remember this. PCl5 is covalent in gaseous state, but bacha, in the crystalline state. In the crystalline state, PCl5 is actually present as PCl4 plus and PCl6 complex. This kind of complex in the crystalline state, this kind of crystals are present. Please understand this very important thing. ठीक है ठीक है ठीक है PCl5, as I told you, because 5 bonds have to be formed, it will be covalent, but it is only covalent in the gaseous state. In the crystalline state, such kind of PCl4 plus and PCl6 minus crystalline structures are formed. ठीक है. Now next we have completed the reactivity with halogens. Now we're talking about the reactivity with metals. Very important. This is another kind of reactivity given with your bacha what? Group 15. Why? Because the group 15 can show -3 oxidation state, right? A negative oxidation state can be shown by the group 15 elements. And we know that what is the property of metals? Metals always show positive oxidation state. That's why they're called metals. Beta, every metal always, no matter what is the condition, can only and only show a positive oxidation state. Hence, metals react with nitrogens, okay, to form nitrides. What kind of nitrides can be formed? For example, it can form binary compounds. Binary compounds with metals. Okay, binary compounds with metals. Group 15 can form. For example, it can form calcium Ca3N2 kind of nitride. Okay, calcium nitride. It can form calcium phosphide also. It can form Na3 arsenic also. Sodium arsenide it is called. It can also form zinc as Sb2, and it can also form Mg3Bi kind of compounds. So these compounds are very important, bacha. But can you see here nitrogen in all the cases is present in -3. Here phosphorus is present in -3. Arsenic is present -3, and here even bismuth is present in -3 oxidation state. Can you see? Because magnesium is more electropositive than bismuth, despite bismuth being a metal, but it is less electropositive than magnesium. Hence, bismuth also is showing a -3 oxidation state. Can you see? So these are all the examples where the -3 oxidation states compounds are formed. So group 15 shows -3 oxidation state with two kind of things. Now, what is the conclusion? Number first, we looked at the -3 oxidation state with hydrogen, right? When we were forming hydrides, the group 15 was showing -3 oxidation state. Again, with the reactivity with the metals, again the group 15 is showing -3 oxidation state. In rest of the elements, with the reaction with oxygen and reaction with halogens, the group 15 showed two kind of positive oxidation states, which were +3 and +5. Is this thing clear to everybody? Is this thing clear to everybody? ठीक है? Beta, it can be called zinc antimonite, है ना? Because this was called sodium arsenide, so this can be called zinc antimonide, है ना? Because this is an antimony. It can be called zinc antimonide. ठीक है? ठीक है? Now, bacha, these are some of the properties of nitrogen gas. You can get in the notes. It is a non-toxic. Obviously, it is present everywhere in the atmosphere. Nitrogen gas, है ना? It is present in everywhere in the atmosphere. It is non-toxic. We're not dying. It is tasteless. Can you taste anything in the air? No. It is not combustible. Is everybody like nothing is catching fire, right? It is non-combustible. It is insoluble in water. It is a colorless and odorless gas. ठीक है? ठीक है? Antimony. हाँ जी. Arsenide. Nide. See, arsenide you write like this. Arsenide. This is arsenide. ठीक है? Arsenide. and the another thing was arsenite. ठीक है? It's not IED, it is IDE. IDE. This kind of suffix you use. ठीक है? Otherwise, you can check the correct name on Google as well, but it can be called antimonite. ठीक है? Next is, we know the structure of ammonia. Bacha, ammonia, what kind of molecule? There are three hydrogens attached, and there is a lone pair of electron over here, right? Lone, this is the structure of ammonia. Now, what is the shape of NH3 molecule? It is tetrahedral. Tetrahedral is the geometry. The shape is actually pyramidal. ठीक है? If somebody asks you what is the shape of ammonia, it is pyramidal shape. ठीक है? Now, due to this lone pair of what is the it is sp3 hybridized. Again, the nitrogen over here is bacha sp3 hybridized. So its geometry is tetrahedral, shape is pyramidal. ठीक है? Now, sp3, what is the bond angle in sp3 which you have been reading in the entire organic chemistry? The bond angle is 109 degree 28 minutes. But can you see the bond angle between here is 107.8 degrees. Can you see the bond angle reduced? Why did the bond angle reduce? Because due to the repulsion of these lone pair. Due to the lone pair bond pair repulsion, this bond angle actually reduces than the normal tetrahedral angle. Hence, it becomes a smaller angle than the normal tetrahedral angle. ठीक है? So this is about the ammonia. Now, bacha, the oxides of nitrogen, very, very important. Please do not forget to miss these oxides. This is a table given in your NCERT. I have not taken this table from anywhere else. This is the screenshot from your NCERT. Can you see even, you can even see the bookmark over here of the NCERT, right? So this is the NCERT table. Please look at this table. What you have to look at, I already taught you about the oxides. We talked about the oxides, right? N2O, NO, N2O3, NO2, N2O4, N2O5, right? And you have to know their oxidation states first of all. All of these oxides, you need to know their oxidation state. The next thing, you need to know their names. You need to know their names, right? Their names, their molecular formula, their oxidation state. You do not need to know the methods of preparation because these are no longer in your course. From this table, what you all need to know, and their physical appearance, if you have time, then please go through it. Please go through it. This can be asked in any format because I do not know. If you do not want to take any chance, and if you have time, only and only then go through this. Otherwise, these three columns are really, really important about the oxides of nitrogen. And I already discussed the oxides of nitrogen, their acidity order we discussed, right? We also discussed their oxidation state and their acidity order, but also look at their names. The next thing you should know about these nitrogen oxides are their structures. Very, very important. You might forget. There's no need to know the angles and everything, but you should know the structure. What is the structure of N2O? What is structure of NO, N2O3, NO2? All these structures are very, very important. ठीक है? Yes. ठीक है? All these structures are very, very important. Please go through these structures. And I want to tell you once again that two kinds of nitrogen oxides have odd electrons in them. Number one is the NO2. This is a odd electron molecule. Number one is the NO molecule. The number two is the NO2 molecule. Again, odd electron molecule. Correct? The NO molecule do not dimerize. This is the NO molecule, which is a odd electron molecule I told you about. Can you see? Here, an odd electron is present one time on the oxygen, the other time on the nitrogen in the resonating structures. Again, in the NO2, again, it is an odd electron molecule. Both the times, the odd electrons are present on the nitrogen. So, but because NO2 is odd electron species are never stable. Hence, what does NO2 do? It dimerizes. Dimerize means what? This one NO2 molecule makes bond with the another NO2 molecule and forms a N2O4 molecule. Okay? So, bacha, NO2 and N2O4 both are the same molecules only. Matlab N2O4 is just the dimer of NO2. This is the main thing that I have to teach you. Otherwise, you should know how to form these structures. And this is the N2O5. The structure is, there is a bridge of oxygen over here. Okay, so these are the resonating structures that you should know about. This is given in your NCERT. This is a screenshot of the NCERT that I just placed here. Okay, now here again, this is a very important question. I just told you, why does NO2 dimerize? Because bacha, NO2 has a odd electron. NO2 is a odd electron species and they are not stable, hence they dimerize, matlab make bond with itself, है ना, with another atom make bond and dimerize. And what is the covalence of nitrogen in N2O5? Very, very important question. Covalence means what? This is a very important word and students don't know what this covalence means. Covalence means how many bonds, number of bonds. That is meant by covalence. What is the covalence of nitrogen in N2O5? What is the structure of N2O5? Look at this structure. This is the structure of N2O5. Can everybody see this structure? The last structure is N2O5 structure. Now tell me how many bonds does nitrogen have in this? What is the covalence in N2O5? Very, very important question once again. Beta, it is not hard to remember the bond angles. Yeah, you don't have to remember these bond angles. That's what I told you. These bond angles have never ever been asked. Okay? On the basis of the previous trend, I'm telling you this bond parameters, the bond angle, the bond length have never been asked except in your organic chemistry. Those bond angles are asked. In the inorganic, not asked. Only what is asked, these resonating structures, which are very easy. See, right now you have 2 months. Even if you start today, if you are learning with me today, even if you draw, like even if you take this entire week and just draw these resonating structures, these will fit in your head because these are so easy to draw. Okay? These are so easy to draw. Okay? What is the covalence of nitrogen in N2O5? What is the covalence of nitrogen in N2O5? No, bacha, Al2O3 does not dimerize. Who told you that? Who told you that? No. No, 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 no. Beta, covalence is number of bonds. How many bonds this nitrogen forms? This nitrogen forms 1 bond, 2 bond, 3 bond and 4 bond. Hence the covalence of nitrogen in N2O5 is 4. Simple. Simple answer. Okay? Now we are reading about the oxoacids. Again, many teachers might say this is out of the course, but this is not. This is so much in the course because in your course, reactivity with hydrogen, reactivity with oxygen is present. And oxoacids are nothing. Oxoacids of nitrogen are when nitrogen forms bonds with oxygen and hydrogen. That is it. So the compound of nitrogen with oxygen and hydrogen is called a oxoacid. Hence their structures are very, very important from your exam point of view. Remember this thing. Now what is the number famous oxoacid is HNO3. HNO3 structure you should know. HNO3 is what? The nitrogen has 3 oxygens attached to it like this. Okay? And 1 OH is attached. That is it. This is the structure of HNO3. This is the structure. What you need to remember, just what is the structure of HNO3, that you must know. Okay? Here can you see that there is 1 OH group present. So, bacha, this OH group is actually called the basicity. This actually defines the basicity of the HNO3 molecule. Basicity means what? Ki how the number of, as the number of OH molecules increases, the acidity also increases, which means what? The H will go out of here. Okay? HNO3 is a monobasic acid, right? HNO3 is a monobasic acid, which means what? It gives away 1 H plus atom, right? When it gives away 1 H plus atom, it is called monobasic acid, and that H plus is actually attached in the form of OH bond. So this describes its basicity. It is 1 monobasic acid. ठीक है? ठीक है? And one more thing I want to remind you, okay, whenever you're studying for your this exam, NEET exam, so there you have another 2 books more with you. Do not forget those 2 books. The first book is practical organic chemistry. Second book is practical inorganic chemistry, right? And in the practical inorganic chemistry, you will again come across many of the reactions from your P block. So right now, what is the reduced syllabus like? In your reduced syllabus, that practical inorganic chemistry reactions are coming, right? And those are again your P block reaction. So in that you will study about a brown ring test, which is a bacha nitrate group test. What group test it is? It is a NO2 minus group test. Okay? NO3 it is a nitrate group test. Brown ring test is actually a nitrate group test, which is again a nitrogen is present, so it becomes a P block element chapter. But right now, these reactions are not given in your P block, but you will read them in the inorganic chemistry practical book. So if you want to do that practical inorganic chemistry with me, I will take another 2 days for that. ठीक है, 2 days I would need if you want to do that very अच्छे से, है ना. Otherwise, in a day, in like 1 hour, 2 hours, I can complete it, but it won't be in that good manner. So if I take like entire 2 days for the entire practical inorganic chemistry book, we can be able to complete all these kind of reactions and how to remember them, what are the tricks to remember them. है ना? I can teach you all of that, but right now I'm just making you aware to not forget to go through two of those books. ठीक है? Ma'am, how scientists got the bond angles isn't so hard. Beta, this is again a very higher class question, which again, when did I learn about these things? When I was in my bachelor's. Okay, after I completed my, like, in the last year of my college, I learned how to check the bond angles, bond lengths. That's when I learned these things. So right now, let's not go into that. After this session is over, I will explain to you. I can. But right now, let's go through these structures. Okay? Now, phosphorus. I told you that in group 15 what happens, every element shows allotropes. Allotropes means what? Different physical forms except nitrogen. For example, phosphorus is present in 3 kinds of different physical forms. You should just know the structures of them. This is bacha white phosphorus. Number first, the structure that you're seeing on your screen is the white phosphorus. This is bacha the red phosphorus. What happens? White phosphorus is a singular molecule. Can you see 4 phosphorus atoms are attached like this? Hence, this phosphorus, this white phosphorus has a angle of 60 degree. Therefore, this is the most strained molecule. White phosphorus has so much angular strain. Therefore, this molecule becomes bacha unstable. And if it is unstable, it means what? It is very reactive molecule. Because of so much angular strain, this is the shape of the white phosphorus, which has 4 phosphorus atoms attached at 60 degrees to each other. So due to this bond angle, it is very reactive. Similarly, next is red phosphorus. Red phosphorus, what happens? These white phosphorus come together in a straight chain just like this. And it is a little less reactive than white phosphorus. Less reactive. Okay? And bacha, your black phosphorus, this is your structure of black phosphorus, which is a hexagonal. All the phosphorus are attached in a hexagonal shape. Okay? And this is somewhat stable kind of phosphorus. Okay? And the structures of few organic molecules are easy to understand. Beta, what are you talking about? I'm not getting your question. Hi Himanshu. Okay. Now this is what a phosphine molecule looks like, right? Again, this is a pH3 molecule. pH3 molecule with a lone pair of electron. I told you its structure is what? Its structure is pyramidal shape, right? This is same as NH3 molecule. Phosphorus is sp3 hybridized. This is a fully filled p orbital, right? So all these things that you should know. And the next thing is phosphine has a very rotten fish smell. This is a very bad smelling compound. So these are some of the things that I'm telling you. These used to be in your course, but right now they are not. But I'm telling you the mota important bigger things so that nothing is left behind. Next is the bond angle is more in pH3 or pH4 plus. Who can answer this question? This is I'm giving you homework. See, I have a very bad habit of giving homework questions. And I need to know the answer in the comment section below today itself. Okay? Bond angle in pH3 is more or in pH4? That is the question. Where is the bond angle more? You have to tell me the answer to this question in the comment section below. Okay? Now I've talked to you about the halides. This is a structure of the trihalide. The PCl3 trihalide has a pyramidal structure. Can everybody see? Pyramidal structure. These are the phosphorus trihalide, and the phosphorus pentahalide has this kind of structure. Okay, can you see that it has 2 equatorial bonds and sorry 3 equatorial bonds and 2 axial bonds, right? Let me change the pen color so that you can see what I'm talking about. These longer bonds are called the axial bonds, right? And these 3 similar bonds. These three similar bonds which are called the equatorial bonds. The equatorial bonds are same in length and the two axial bonds above and below are again similar in length. But axial bonds are longer than the equatorial bonds. Why? In order to reduce the repulsion. In order to reduce the repulsion, the axial bonds which are above and below the plane are actually longer, and the which are in the plane, the equatorial bonds are actually shorter in length. Okay, this is the another thing that you should know about the phosphorus halides. Now let us do some question. Identify the incorrect NEET 2019 question on your screen, everybody. Everybody, NEET 2019 question. Identify the correct statement related to PCl5 from the following. Identify the correct statement. Abhi, we just learned about the PCl5 molecule. Trigonal bipyramidal. What is that shape called? I forgot to write it over here. The shape is called trigonal bipyramidal. Right? Bipyramidal. You learn all of this in your... one second. Hannah? You learn all of this in chemical bonding. Who can answer this question? NEET 2019 question on your screen. On your screen. Identify the correct statement related to PCl5. Which is the correct statement among this? Axial PCl5 bonds are longer than the equatorial PCl bonds. PCl5. Incorrect statement you have to identify. Which is wrong? A seems correct. Correct. This seems correct to me, right? Because axial PCl bonds are longer than the equatorial. Yes. PCl5 mol is non-reactive. This is the incorrect statement. I already found my answer. Why? PCl5 bacha is a reactive molecule. Why is it reactive? Because the two bond lengths are unequal in length. If the two bond lengths, the equatorial bonds are shorter, the axial bonds are longer. Hence, what is happening? The molecule does not have any symmetry in it, and unsymmetrical molecules are reactive molecules. So PCl5 is non-reactive. No, it is very much reactive. Hence, B seems to be the correct answer. ठीक है? I have already found the incorrect statement. Now, next is oxoacids of phosphorus. Again, what are oxoacids? The oxoacids are again when with phosphorus, what is attached? Oxygen and hydrogen. The compounds of phosphorus with oxygen and hydrogen are called oxoacids of phosphorus. I am going to teach you a trick by which you can form the structure of any oxoacid without any difficulty. Now, first, number one thing that you should know, how to form the structure of phosphoacid. For example, remember one thing. If one phosphorus atom is there, there will be two kinds of bond will be there with it always. Number one kind of bond is the P double bond O bond will be there with one phosphorus, and the other bond that is fixed is the POH bond. These two bonds which are fixed in every oxoacid of phosphorus, what you have to do, you just have to draw these two bonds first of all, and then just adjust with the number of hydrogens and the oxygens present. What I'm talking about, I'll just let you know with examples more. And the other thing that you should know about the basicity is the number of OH groups. Can you see the OH group attached over here? That decides the basicity of your oxoacid. Basicity actually means how much acidic is your compound. For example, a monobasic, for example, I just told you HNO3 is a monobasic compound. Monobasic compound, which means what? It can give away one H plus, right? Can give away, for example, H2SO4. It can give away 2H plus. So it is a dibasic acid. It is a dibasic acid because it can give away 2H plus ions. So here, basicity actually in real terms means we're talking about the acidity here. Okay? So as the number of OH group will increase, the acidity or the it will be monobasic, dibasic, tribasic, that will also increase. And the number of pH bonds will increase. It will decide its reducing character. As the pH bonds are more, that compound will be more reducing in nature. Right? Right? For example, the number first oxoacid on your screen is hypophosphorus acid. How can you draw the structure of this? H3PO2, I'm going to teach you the very basic easy method. H3PO2 is the molecule given to you. What will be its structure? I just told you that two bonds are fixed for the phosphorus. Number one is the P double bond O bond. So one oxygen is used in that. Okay? And the other oxygen is used in the POH bond. So two oxygens I've already used. Now what I've left, and I've used one hydrogen. Now two hydrogens are left. So I will attach two hydrogens just like this. Are you understanding? With one phosphorus, one double bond O and one OH bond is fixed. Now when I did that, I used up both the oxygens and one of the hydrogens. Now only two hydrogens were left, so I have just one way to draw those hydrogens, which is pH here, pH here. So this is the structure of hypophosphorus acid, which is H3PO2. Here the phosphorus is in +1 oxidation state. Okay? Now look at this structure. This is the structure I draw, right? Now this has one OH group, which means it is a monobasic acid. What is its basicity? Its basicity is 1, right? And it is too much reducing. It has a very high reducing power because there are two pH bonds present over here. Everybody can see that basicity here is 1. Remember this thing. Now the next, hypophosphorus acid is a good reducing agent. Remember this line. Why? Why is it good reducing? Because it has two pH bonds. Correct? So as I told you, as the number of pH bonds increases, the reducing nature also increases. Okay? As it has two pH bond and therefore it reduces bacha AgNO3. What does it reduce? It reduces AgNO3 just like this. Okay? Just like this, it reduces AgNO3. Here the Ag was in +1 oxidation state. And here the Ag becomes in 0 oxidation state. Correct? So it has reduced the Ag and itself got oxidized. Here phosphorus is in +1 oxidation state, right? I just told you what is oxidation state here. Sorry. +1 oxidation state. Okay? And here it became how much? H3PO4. So 4 2s are 8. 8 minus 3 is 1, 2, 3, 4, 5 plus 5 oxidation state. Okay? From +3 we are making it a +5 oxidation state. Now next is H3PO3. How to draw its structure? Again use the same funda. With the phosphorus there will be a double bond O. I have drawn the double bond O, ma'am. Next will be with the phosphorus there will be a OH bond. I have drawn the OH bond. Now ma'am, again one oxygen is left with me. One oxygen and again two hydrogens are left with me. So one oxygen will be used like this and the other hydrogen will be this. So this is the structure of orthophosphorus acid where the oxidation state is +3. Correct? Can you see? Now this is the structure of orthophos. It's easier to draw like this, right? Just draw, write the P and then draw double bond O and then OH and then just fill the valencies. Now here, what is the basicity? It has two POH bonds. So the basicity is 2 and the reducing character decrease because it has just one pH bond now. Now how to draw the pyrophosphorus acid? Again, very, very interesting. Now there are two phosphorus here. So with both the phosphorus, I've attached two oxygens just like this. Okay? Everybody is understanding? Now with both the phosphorus, I have to attach the OH bond because this is a standard molecule. Now what is remaining, ma'am? I've already used 4 oxygens. Now one more oxygen is remaining. So bacha, the other oxygen you can make it in between just like this. And the other hydrogens you can make it just like this. So this is the structure of pyrophosphorus acid. Okay? Everybody, see, it is so easy to draw. You just have with every phosphorus make double bond O and OH groups and then just fill the valencies just like this. What is its basicity? Again, two OH groups are present. So basicity will be 2 obviously. And again, is it reducing in nature? Yes, because it has 2 pH bonds. So it is also reducing in nature. Again, hypophosphoric acid. Again, you can draw the structures in the same way. With the phosphorus, there will be 2 like this atom. Here it will be OH atom. Here it will be again OH atom. Okay? Here again 2 OH. Here I can draw like this. I can draw like this. Okay? 1, 2, 3, 4. I think this is the structure. See, this is the structure. This is the structure of hypophosphoric acid and you must know how to calculate the oxidation state as well. This is a non-reducing acid. Why? Because It has no pH bond, therefore it cannot reduce. It is a non-reducing acid, but its basicity is 4 because there are 4 POH bonds. Okay, everybody is understanding this? All the best बच्चा दवाई for your maths exam. Oh, ठीक है, orthophosphoric acid has a structure just like this, very easy. Once again, basicity is 3. ठीक है, then pyrophosphoric acid again has a structure like this. Its oxidation is 5. What is its basicity? Its basicity is 4 and it is again non-reducing in nature. ठीक है, now cyclotrimetaphosporic acid, very very important. When you have structure like this, HPO3 with the whole thrice. So what is its structure? It is actually a cyclic structure just like this. Correct? It is a cyclic structure just like this. ठीक है? Its basicity is actually 3. ठीक है? Next is polymetaphosphoric acid that has a cyclic structure. This has a straight chain structure just like this. ठीक है? So these structures are very very important. Again, this is a table from your NCERT given. What is given? The name is very important. Look at the name of the acids. The hypophosphorus acid is also called phosphenic acid. The orthophosphorus acid is also called the phosphonic acid. Okay, and their oxidation states are important. And what are their structures? I've already shown you all the structures here. The number of bonds are just written. How can you don't have to remember? I just taught you how to draw the finest structure. Like that, if you use that trick to draw any structure, you will have 0 wrong questions ever. And preparations, you don't even have to bother. Okay, only till here, only these 4 columns you have to study: name, formula, oxidation state and characteristic, because preparation is no longer in your course. Preparation is removed from your course. Only these things will be asked in your exam. ठीक है, next. Now we are again doing the PYQs. Who is going to do the PYQs with me? Which is the correct statement for the given acids? This is a NEET 2016 phase 1 question. Which is the correct statement of the given acid? C from group 15. These oxoacids are very very important. There are high chances of questions coming from the oxoacids. Remember this thing. Okay? Now, as I told you that you have to remember the common names of these acids. Of phosphonic acid, as I believe, was the H3PO2 acid, right? So phosphenic acid was H3PO2, is a monoprotic acid, while phosphonic acid was H3PO3, which is a diprotic acid. Both of these statements seem to be true to me. See, this is the phosphenic acid H3PO2, phosphonic acid H3PO3. So phosphenic acid has only one POH group and the phosphonic acid has 2 POH group. Hence, this is a monobasic acid and this is a dibasic acid. Right? 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 Everybody is understanding this? Okay, so the correct answer here seems to be A. A once again. Okay. Now, strong reducing behavior of H3PO2. Who can draw the structure with me? I told you. See, if the molecular formula is given to you, then drawing the structure is the easiest thing. Because I know with every phosphorus, I have to first make a double bond O bond. Next, I have to make a POH bond. Now, I have to count the number of oxygen. I've already used 2 oxygens. Okay, that game is over. Now, there are 2 hydrogens remaining. So, I will attach 2 hydrogens like this. So, this is the structure of H3PO2, which is actually a phosphenic acid. So, it has asked in AIPMT 2015. Why is H3PO2 strong reducing in nature? Strong reducing behavior of H3PO2 is due to what? Who can answer this question for me? Who can answer this question for me? Yes, Swacho. Este Swacho. Who can answer this question for me? Please let me know. See, we have completed group 13, group 14, group 15, and in the last lecture, that's going to be a little bit more bigger because we're going to complete 16, 17, and 18. 18 group, and we're going to complete P block on Monday. On Monday, that's going to be the lecture there. Okay, on Monday at 11 a.m., we'll try to do it. Okay, first answer I got with Jyoti Gera is presence of 1 OH and 2 pH bonds. Very, very good. The option seems correct. I mean, how will you know the answer? Only if you know how to draw the structure. If you know how to draw the structure, none of the questions will be wrong. Very, very good. And also know their common names. I'm again and again telling you. Okay? because I've made your like your whatever you say learning of P block very easy. But if you ask me na, nobody puts in this much effort in the P block. When I was in 12th standard, 11th standard, nobody even taught me P block, you know, because there was so much of course. P block was like do it yourself. And now when at that age, if you give something to do it myself, especially in the NCERT, there are no trends given. They're just tables with values given, and I had no patience or no time to even form trends out of that. So what I'm doing here right now, I'm just making your work so much easier, and I'm giving you bullet points for each and every detail mentioned in NCERT. Please make use of these notes. Please make use of this time. You have 2 months, very precious, and this is the exact amount of time you actually need to crack your NEET exam. Please, malab, just understand this thing. It is enough. 2 months are enough to crack the NEET exam. You do not need the entire, like obviously if you're preparing from the entire year, you do not have that much pressure. But even if you start studying right now, no, the difficult part for you guys is the physics part, right? So just start practicing. Start practicing physics, start taking physics. What are the important topics from physics? Start taking it. Because your chemistry syllabus is already reduced so much. You know, you just have 10 chapters, I guess, from the 12th class, and even like 10 from the 11th probably. There are not many chapters in the course. Okay. Next, option D from structure. This AIPMT 2012 question. Which of, sorry, I get derailed a little bit while teaching. Acha, AIPMT 2012 question, bacha, on your screen. Which of the following statements is not valid for oxoacids of phosphorus? Which is the wrong statement? Who can tell me? Again, you have to know the names of the, what is the orthophosphoric acid is used in the, see, manufacturing will not be asked, so just eliminate this thing. Hypophosphorus acid is a diprotic acid. Does this seem true to you? Option D from the structure, somebody is saying. All oxoacids contain tetrahedral 4 coordinated phosphorus. Is this statement correct, bacha? I think this is correct. Something that is not valid, not valid. And all oxoacids contain at least one PON and one pH. This is also true. This is also true. Correct. Everything seems to be true. So the hypophosphorus acid is a diprotic acid seems to be the wrong statement. Let us look at the hypophosphorus acid is a monoprotic acid. Can everybody see? Hence, B statement is not valid. So this seems to be the correct option over here. Right? Again, EIPMT 2012 question. This I'm not going to answer. This is, you are going to answer this question. In which of the following compounds nitrogen exhibits highest oxidation state? Who can tell me the answer to this question? Nitrogen exhibits, you just have to calculate the oxidation states of the nitrogen. Very beautiful. I love this question. This is a very, very beautiful question. Let me know. I just told you, we just talked about these things. Who can tell me what is the highest oxidation state? What is the answer? I'm giving you 60 seconds. 60 seconds. Just take out copy and pen and write down their oxidation state. Only and only then you can answer the correct option. Otherwise you cannot. Otherwise you cannot. I'm telling you again. First answer I got by Jyoti Gera's SD Swacho. No, this is the previous question I was answering, right? For this question, AIPMT 2012 question, first answer I got is by Priya D. Priya is answering D. Swacho answer, I'm looking for your answer, Swacho. And also Jyoti Gera, please answer. Please answer, I'm waiting for your answer and then I will let you know the solution. Then I will tell you the solution because I've already given you one homework question. Right? See, group 15 we have finished now. We are only left with PYQs and then we are done with group 13, 14, 15. 3 groups completed. Very easy. Swacho has answered me B. NH3. Okay, Swacho. Very good, Swacho. Okay, and Jyoti Gera, do you want to try? Do you want to try? Should I wait for you? Chalo, I will tell you. What is the oxidation state of nitrogen over here? I told you. Nitrogen here is more electronegative than hydrogen. Hence, nitrogen will get the negative charge here. Therefore, hydrogen has what charge? Hydrogen has a +1 charge. How many hydrogens are there? 4 hydrogens. So, +1 into 4. plus, I don't know the oxidation state of nitrogen, so x plus how many? 2x. Okay? So what is the answer for this? So 2x plus 4 is equals to 0, right? So therefore the answer of x comes out to be what? Here, so x comes out to be here becomes minus 4 upon minus half. Minus 2, sorry. So here nitrogen is in minus 2 oxidation state. Is this thing clear to everybody? The nitrogen is in minus 2 oxidation state. Correct? Correct. And here in NH3 again, the hydrogen here is in minus 1 oxidation state. Hence the nitrogen here is in minus 3 oxidation state. Correct? Similarly here what is happening? What is happening? The oxidation state of nitrogen here again. Sorry, hydrogen is plus 1 oxidation. Plus 1 oxidation state. Again here hydrogen is in plus 1 oxidation state. So what is the oxidation state of nitrogen? It becomes minus 1 by 3, isn't it? Here, what is the oxidation state? I will again take x plus 2 plus minus, okay, minus 2, and here it will become plus 1. Okay, so this will cancel. So here nitrogen is again minus 1 oxidation state. So these are the oxidation states given to you. Here nitrogen is minus 2, here minus 3, minus 1 by 3, here it is minus 1 oxidation state. So what is the correct answer? See, very good. Priya has given me the correct answer right now. So, bacha, what is the highest? Highest means what is the highest number here? As we know, smaller the negative number, more is the value of it. So, this is the highest oxidation state shown here. So, the answer is C. Very good, Priya. I want to clap for you. Clap for you right now. ठीक है, C option. Correct. Everybody understood this? See here, the nitrogen is in minus 1 by 3 oxidation state, which is a very small negative number. Small negative numbers are larger in value, right? So this is the highest oxidation state. Now, AIPMT 2010 question on your screen. How many bridging oxygen atoms are present in P4O10? So this is a kind of, I know, this is like a little out of course questions, might seem like that. That's why I've included this. This was asked in AIPMT 2010. So it has the chances to get repeated once again. So you must know the structure of P4O10. So P4O10 again has a structure like this. For example, with every phosphorus, one phosphorus here, the other phosphorus here, the other phosphorus here, the other phosphorus here. With the fourth phosphorus, I've attached 4 oxygens just like this. Okay? So 4 oxygens are gone. Now I'm left with 6 oxygens. So now I can form bridges like this. 1 oxygen bridge, 2 oxygen bridge, 3 oxygen bridge and 4 oxygen bridge. Okay? So this is how 4 more oxygens are used. Now again I'm left with 2 oxygens. So bacha, 2 oxygens I can make a bridge like this over here. The other oxygen I can make a bridge like this over here. So this is the structure of P4O10. Can you see? So how many bridging oxygens are there in this structure? Very easy to count again. How many bridging oxygens are there? 1, 2, 3, 4, 5, 6. Can everybody see? 6 bridging oxygens. So the answer is 6. Okay? How did you draw the structure? By using the same funda you used while drawing the oxoacids of phosphorus, right? Same funda I use na. With every phosphorus I attached 1 oxygen atom just like this. Hai. So use the same funda to draw this structure. I know this might seem a little out of course question, but the NTA didn't regard it as out of course. Out of course because they said that this kind of oxides of phosphorus are there in your course, and hence I've included this question. If it has a chance of repeating again, you should know how to approach this question. This is the structure that I just drew for you. Very easy to draw once again. Next is oxidation states. Again, as I'm not going to tell you again and again. So very important category of question once again. So all the oxoacids of phosphorus, you must know the oxidation states of phosphorus in this. Okay, the answer will be, okay, I will not tell you. Let me know in the, okay. So this is again I can give you as the homework question. So you have 2 homework questions now. I want the answers to both the homework question down below. We have completed the group 13, group 14, group 15 with all the PYQs ever asked in your NEET exam. Okay. So here I end this thing. Now that it will be a part 3 on Monday, that will be the last part for the P block, and we're going to be done with the P block, with the PYQs, with the NCERT questions, with everything that can has ever been asked in your exam. Okay, so this is the best place. I think okay, I want to say that I give the best notes. That is not exaggeration, because I also put efforts in it. I put as much efforts as if I am the one who's going to take the NEET exam. Okay? So you can just depend on my notes fully fledgedly, because I also keep on updating them. These are not like old notes that I've been using. These are very new. I keep updating them for you guys with all the PYQs, all the new things that are added. Okay? And if you want more notes and these notes also, then you can join our Telegram channel. The link is again in the description box below. You will get all the notes, and I will also share my Telegram ID so that you can ask me doubts on them. Thank you for attending today's session. My name is Nandini ma'am, and we will learn inorganic chemistry on this channel with me. ठीक है? Perfect. 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 Priya has already answered. But let me know in the comment section. This live chat will go away after a while, right? Let me know in the comment section. Also, please give me some feedback. Ki, ma'am, whatever, positive, negative, ma'am, I didn't understand this. Ma'am, you were going very fast, very slow. Whatever feedback, so that I can improve myself. Because I'm here to teach you guys. If there is something else you want from me, if you are looking for another kind of thing from me, what are your expectations, anything, everything you can know in the comment section, not in the chat box, right? Comment section after the video live stream ends. And please like the session, subscribe to the channel if you're not subscribed. Thank you so much for joining. Bye bye, all the best for your exams if your exams are going on. Okay, thank you Swacho, thank you for the, and please write this in the comment section below so that it stays there for a while. Swacho, write that in the comment section. Thank you.